GM, everyone. Today is day 2 of this beautiful Devcon in the Southeast Asia. My name is Eric. I'm from Africa. My state is Ghana. I've been working in this ecosystem for the last few years, and I'm building the human layer on top of Ethereum. So I know you guys are all core devs. It's going to be interesting. And this morning, we'll be going to look into rethinking Ethereum account model. And you could have had an amazing better person to give us this interesting conversation than Will, who happened to be a former core dev and author of account abstraction. So everyone, help me welcome our first speaker, Will.
Cool. Hey, what's up, everyone? How you doing? This should be a quick talk. I think it shows expert. I'm actually not going to go that deep. So I am a, actually, let me go back. Okay, so I think we should rethink some concepts of the Ethereum account model and also the account models that we're using on L2s, specifically to scale. This is a forgotten mechanism to scale. I'll go into some things here really quickly. I think deterministic state addresses and state access is really important in order to accomplish this. I think there has been discussions of access lists in the past that didn't necessarily get enough traction, but this actually can provide significant scaling, indexing improvements, and security improvements to Ethereum as a whole. So with access lists or account lists, you know the state ahead of time that you can touch. This allows for being able to do things like execute concurrently. Since you know the different parts of a graph of nodes that you are touching, this can be enforced by the runtime. It prevents any overrides. For example, if 2 swap transactions are happening through the same protocol, but the same token, this can actually happen concurrently. So I sort of think of this as another mechanism for multiplexing, spawning parallel processors. Another way to think about it is knowing your I/O ahead of time, and or having essentially a built-in mechanism for sharding as well. I think this also works really well for multiple concurrent proposers. This kind of go hands in hand. It's really great. Again, I'll go into ERC20 as an example. ERC20 sort of represents a massive global state that everyone can touch. And anytime anyone touches it, this sort of creates a global lock on the system. And so, you know, I sort of mentioned this, so, you know, I'll go ahead and skip this part. So this is like, I got this silly graph here, but you can see there's different parts that are being touched. And in this case, you could split this up into 3 different concurrent processing or execution, which can actually make things really interesting. From the security side, this is really helpful as well. I think security and the data side, like once we're indexing and once we get things to scale and get really, really fast, these are things we think about. We don't think about this a lot currently. In the Ethereum ecosystem, I think there's maybe some exceptions, TJ's here. But as things scale really big and we get to the point that we're dealing with like hundreds of thousands of transactions per second across all the L2s, actually having mechanisms that inherently provide better indexing via the account model can be extremely helpful. But again, approved pattern on ERC20s, I'm just giving specific concrete examples. Obviously, we all know it's a disaster. You don't know ahead of time when you look at the shape of a transaction. You don't know what accounts will end up being touched. You don't know where the funds can end up being spent. You don't have a deterministic way to know what reads or writes are going to happen. If you know this ahead of time, then this actually prevents a lot of safeguards that you have to do on the contract layer. And this is what I call an account-centric model. I think we've seen this in some of the concepts of like Move ecosystem. I think SVM has done this. There's been some experimentation with other models as well. And varying parts of them are interesting. So this also helps for things like memory, programmatic ownership patterns, memory ownership patterns across different levels of the stack when we're calling calling between different contracts. So Yeah, so also it's really fast at the pre-processing level from a security perspective. I think what's going to happen is we're going to have a lot of wallets that are going to look at the fingerprint of a transaction ahead of time and let you know without processing on chain or simulating on chain what are sort of security aspects that could be vulnerabilities. And so this actually makes this really clean. This is where you can have like a easily readable format of what your transaction's about to do. Yeah, that's sort of the thing. I'm all for state access lists. Again, I'd love to see this come back and have this as part of mechanisms to make things run concurrently on Ethereum and the L2s and scale that. That's all. Any questions?
Okay, thank you all. Do you have questions? Okay, I saw your hand, so.
That was good. So yeah, I have this question. Like, there was a paper published maybe last year about like access list by some people at Zurich, and the outcome of the paper is essentially the discount is not high enough. Many people who are using access lists are misusing it. Many clients are implementing it incorrectly, and so on and so forth. So, what steps concretely we should take to solve those problems? Increasing discount or what?
Yeah, I think in general you need to enshrine more into the actual consensus on rules on how access lists can be used, different aspects like that. And then also from the security side, it's really important. And then I also think, I think that particular study looked at it comparing to what the current patterns are on chain. I think if you make the changes to have a model like this, some of the programmatic patterns will change and therefore will lead to scaling naturally. But yeah.
Next question? Okay.
Beautiful. So the ETH research post or discussion that was talking about state access lists way back in the day is cited by Fuel, and there's been some extra thought on that and some developments. Are there any differences between your absolute dream, like, you know, pie in the sky, perfect if you were a dictator model of state access, and what Fuel is currently running?
I think what Fuel is doing is elegant. So I think it follows a more account-centric model. It's like sort of like an UTXO model is the way that I see it. And with UTXO style models, you have better determinism around accounts, and it's much easier to see what you're going to touch ahead of time and what you won't. So I think with regards to Ethereum, it'll never go to that extreme. But I think there's good balances to where we can sort of keep some of the beauties of the current account model, but also have additional speed and security. Thanks.
Last question? Okay.
Oh, TJ. Hello.
Can you just define these lists, and then how do you calculate this list prior to the transaction happening? I never understood that.
How do you, oh, okay. So basically any state that you access, you can deterministically, right, you can have a hash that represents that state that you're going to access, for example. And so anything that you touch, any of those state locations, would be referenced via a list of hashes, essentially. That's one mechanism to do it. There's a bunch of different, but yeah.
How do you know that without running the transaction?
So you have to, how do you, sorry?
How do you get that without running the transaction first?
Yeah, so the user would run the transaction ahead of time, right? Or may run the transaction ahead of time before they form that. And then it's enforced in the consensus protocol, if that makes sense. So that means people who are listening for transactions that are coming in, wallets that are trying to validate the security of a transaction, things like that, know that these are the things that are going to be touched, and there's no like bit flip that might happen that might suddenly have it touch like 10 other accounts that could end up siphoning funds or do some type of bridge attack mechanism, if that makes sense.
Okay. Thank you so much.
Let's talk later.
Thank you so much, guys. Let's give a hand of applause for Wales. And thank you for your amazing questions. Like I said, it's going to be interesting this morning. Our next speaker is Mark. And Mark is going to talk with us on encrypted mempools, a path to Ethereum L1. So help me welcome Mark to the stage.
Hello, my name is Mark, and I work as an Ethereum core developer for Nethermind. Recently, I've been working on implementing the Shutter encrypted mempool in the Nethermind client. Today, I'll be giving a whirlwind tour of the encrypted mempool design space and sketching a path towards enshrinement on Ethereum L1. Let's start with how a transaction normally ends up on chain without an encrypted mempool. So the user gossips their transaction, in this case, a swap from ETH to donut tokens, and eventually it reaches the proposer or builder for this slot, who can decide to include it in their block. What's the problem with this? The first one is front running. So the proposer or someone else is able to insert their own transactions ahead of the users, front running them. They know that the swap will increase the price of donut tokens, so they can buy up those tokens first and make a profit, while the user gets worse execution on their trade. They can then sell off the token afterwards to make this a sandwich attack. This can also be a problem in other applications, such as in an on-chain strategy game. Imagine you can see your opponent's moves and front-run them with your own. The other problem is censorship. This is when the proposer doesn't include the user's transaction at all. Encrypted mempools are a solution to this. So the user posts their transaction encrypted in a public constraint, and the proposer is required to include all transactions from the public constraint in a predefined order at the top of their block. We need one extra component for this, known as the keeper, whose job is to publish the public key and release the secret keys just in time for the proposer to decrypt and include the transactions. There's a spectrum of possible keeper designs, ranging from trusted to trustless. In my opinion, only the most trustless of these will be suitable for the high standards of L1. On one end, we could have a trusted party with access to the secret keys. To improve on this, we could have the secret keys be stored inside a secure enclave, such as Intel SGX. This is what Suave does. With a threshold encrypted mempool, such as Shutter, we fragment the master secret key between a decentralized committee of keepers, requiring a threshold of 2/3 of them to come together to reconstruct the secret keys. Finally, we have delay encryption, where to reveal the secret keys, you have to evaluate a sequential function, which will take a certain amount of time. This is a relatively weak security assumption that everyone is able to evaluate this function at a similar speed, which can be achieved when specialized hardware is widely available. And I think this approach will be suitable for L1 enshrinement in the future. Now let's consider the design of this public constraint. So this constraint should be available to everyone to download, and its construction should be as permissionless as possible. So any user can add encrypted transactions to this public constraint. One approach is users posting their encrypted transactions to cool data. This is quite permissionless, but cool data can be expensive. Another approach is users sending their encrypted transactions to the proposer, who then constructs the constraint and posts it to blobs. But this is more permissioned. And there are other approaches here. So we could imagine a random subset of validators constructing this public commitment. And there's quite a lot of overlap here with inclusionless designs. Unfortunately, in the worst case, we can never be completely permissionless. Whoever has power to decide which transactions go into this public constraint could, for example, demand proof of OFAC compliance. However, assuming there is some legal protection for using encryption and encrypted mempools become the default, it's unlikely this would be a problem. So there are different approaches to ordering. I think priority fee ordering seems like a reasonable solution. In the future, once the cryptography is more matured, we might be able to do more advanced block building strategies using homomorphic encryption. Using this, we can perform ordering on the transactions while they are still encrypted, replicating the functionality of secure enclave designs. So how are we going to enforce proposers to include a transaction? We want to make them choose between including all of the transactions in the correct order at the top of the block, or all of them being invalidated so that the proposer would lose out on all of those tips. There are two different approaches here. We could enshrine into the protocol, so we tie the block validity to correct inclusion, or we could have an out-of-protocol solution, so we check for correct inclusion with a smart contract. In the long term, enshrinement would be preferable, but until then, we'll have out-of-protocol solutions. We've proposed EIP 7793, which is a relatively minimal change that will support these out-of-protocol mempools to check for correct inclusion. And this allows a smart contract to tell where in the block is being executed. The final thing to consider is hiding transaction metadata. So when the user broadcasts their transaction, they can leak information such as timestamp, IP address, and size. We don't have time to cover this, but there are various approaches that can be used to hide this information. Thank you for listening.
Thank you, Mark. Thank you for the session. Do you have questions for? Oh, wow, interesting. Okay, I saw your hand first.
I have one question. Like, do your approach going to add the overhead to the process to include the transaction into the block? Actually, like you have to do everything in the rank of the block time to make sure that, yeah.
I think there's relatively minimal overhead. So the user encrypts their transactions, and I guess it would add 1 slot of latency. So with Shutter, when we use call data, we're going to have 1 transaction where we post, and there can also be an overhead in terms of gas fees for this post. And then after that, then we just have to decrypt and include that transaction.
As you mentioned, like the MEVs is all about an deterministic order of transaction. But then, do you think like the encrypt mempool is something like very overkill for this problem?
I don't think it's overkill, really. I mean, yeah, we can't necessarily eliminate MEV entirely, but this does give us some front-running protection.
Next question? Who? Okay, here.
Hey, are there situations where an out-of-protocol mempool cannot protect against front-running? For example, if there's a chain reorganization, you have the old block, then you could front-run at the next block for the next block, right?
So, I mean, yeah, so these... I think there are some situations. I mean, with our protocol solutions such as Shutter, like the validators have to register beforehand, so you know like which proposers are signed up to use the out-of-protocol solution, and the keys would only be released in these cases. If the proposer doesn't include the transactions at all, then there's a chance they could be front-run in the next one. But that's why we need this. We tie the block the validity of the transactions to that slot, so no one can then later include these transactions. But you have potentially leaked some information about your transactions.
With Shutter, currently proposers are trusted, right?
Yeah, at the moment. But I'd say this is like just a step towards improving, so you can like remove these trust assumptions.
Do you have one more question? Last question? Okay. Last question? Yeah. Okay, go here.
Yeah, so from like the user experience, front-end user experience point of view, like how is this encrypted mempool superior to the flash bots? Like in terms of, say, avoiding the sandwich attacks? Yeah.
I'd say from the user experience perspective, there's not really a difference. It just depends on your own personal like trust model. So as I said, sort of Flashbots Protect, for example, is like, I don't have the slides, okay. So it was like the most trusted approach on my thing, whereas like we can progressively move to more trusted solutions so that you don't have to trust Flashbots to do this.
All right, thanks so much, Mark, for this session. If you have more questions, please you can meet Mark and then get to deep dive. Thank you so much. Let's give a hand of applause for Mark. Wow, I'm learning. I'm not a developer, but it's getting very intense now. The next session is going to be an amazing man who is going to lead us into a new session. His name is Marcus, and Marcus is going to speak to us on the universal ECC, that is elliptic curve cryptographic use cases for P256 pre-compile in decentralized internet infrastructure. Ooh, that's, even the topic alone is confusing to me. Mark, please engage your audience. Audience, let's welcome Marcus to the stage.
Whoa. Okay, this is actually going to be a pretty non-technical talk, believe it or not. My name is Marcus. I'm a meta-governance steward at ENS DAO. And today I'm going to try to convince you that we should implement the P256 precompile in the L1. First of all, I just want to gauge the audience a little bit. How many of you have traveled over 20 hours to come here today? Raise your hands. Okay, hats off to you. You guys are the best. Okay, how many of you guys have an ENS name? Okay, for those who don't, you should definitely get one today. Meet me at the ENS booth and I'll help you out with that. And how many of you guys have more than one login across different platforms, like your bank accounts, social media, et cetera, et cetera? Yeah, I do too, pretty much everyone. So basically what I'm trying to do today is convince you that a single login is much more effective and much more useful than various ones, obviously, right? The problem is that for those of you that don't know, there might be a security concern with the P256 precompile. And I'm not going to get into the technical details of that today. I'm just going to try to plant a seed in your head and ask you to consider implementing this in the EVM. If you are a core dev, if you meet up at the ACD calls, please take this into consideration. So let's begin. So the problem is digiphrenia. What is this? This is a term coined by Douglas Rushkoff, and essentially it's the feeling of having your identity fragmented across different platforms. And this kind of leads to a lot of tension, like internal tension, a lot of anxiety, a lot of anger, depression, and you know, this is endemic to our terminally online generation, right? So we really want to find a way how to alleviate it, and I'm personally not of the opinion that we should be taking over, you know, drugs or anything like that to do that. There's a more simple solution, right? Again, when you have your identity fragmented across different platforms, it leads to serotonin and dopamine deficiencies, which leads to all these like really bad things, and you do really bad things once you feel really bad, right? So fragmented identities are bad for your health, and so what can we do about this, right? So what I'm proposing today is an idea, right? A hypothesis for a unified identity framework. And so what this means is to have more sovereignty, more control, and more self-empowerment over your identity online across different platforms. And I'm not just talking about Ethereum, I'm talking about the entire internet, right? And ENS serves as a bridge from Web3 to Web2, but there's a blocker, right? Before we get to that, I just want to reiterate that having a unified identity across different platforms would lessen the tension that we are all experiencing today as a terminally online generation, right? So universal logins with ENS, right? For those of you who are familiar, you probably connect your wallet and have your ENS set up, and you can receive and send payments with your ENS. It makes it super easy, delightful user experience. But I personally would love to, for example, log into my Chase account with an ENS name. I'd love to pay my bills with my ENS name. I'd love to apply to college with my ENS name. I'd love to do everything with my ENS name. And that's not possible today because the P256 precompile is not currently implemented in the EVM. And there was an EIP 7212, that was under consideration that eventually became a roll-up improvement proposal. and that's been implemented across different L2s. But essentially, the path to 1 billion is actually much easier than we are led to believe. It's actually already there. We just need to make this consideration of integrating the P256 precompile into the L1. Yeah, so that's pretty much it. Just a seed, something for you guys to think about for the rest of your day. Here are some prompts for the Q&A if you guys want to go ahead and ask. And yeah, that's my talk. Yeah.
Thank you. Questions time. We got a question. First one. Okay. Oh, I'll try. Okay.
Hey, what's your name?
Hey, my name is Lance.
Hey,
I'm
Lance.
building a project called Saray, and we use P256 verification in our project twice, one for WebAuthn and one for TLS Notary.
I love that.
We end up spending 600K gas total on these transactions, and I was wondering, why hasn't P256 been a precompiled since the beginning? I mean, it makes sense.
Yeah, so that's a great question. So everyone here is familiar with Edward Snowden, and I believe that he's disclosed that there's a potential backdoor risk. It's a pseudo-random curve, right? So the Ethereum L1 is it's a Koblitz curve, so it's deterministically conceived, whereas the P256 is a pseudo-random curve. So there's this concern that there might be a backdoor that the NSA or some other agency might have an ability to take advantage of. So that has not yet been proven, and there is evidence towards it not being a conclusive thing. But I think a lot of people here, I don't mean to offend the audience, but I think you guys might be a little paranoid. Sorry. Yeah.
Next question. Okay.
We got two here.
I tried.
Hey, what's your name?
Hey, my name's Brian.
Hey, Brian.
I'm just playing devil's advocate here.
For sure.
Why can't we get the rest of the world to adopt the K curve?
Pardon?
Why can't we get the rest of the world to adopt 256 K1?
Why can't we get the rest of the world to adopt the P256 curve? Or the K curve? Oh,
yeah,
okay, like do it the other way around.
Yes.
Oh, man. So essentially, like every enterprise business has adopted this NIST-approved curve. And, I mean, I guess we can. Like if we all came together and just kind of created a proposal to do that. But I feel like that would be like an uphill battle, in my opinion. But I mean, feel free to argue against that.
Last question. Guys, let's do this. Last question. Okay, I got a question for you.
Okay, sir.
So I'm from Africa,
Cool.
Ghana, and before L2s, Ethereum was like no-go area for most of us. I'm imagine paying $10 for just a gas fee. What's the future in terms of making it easy for early devs who doesn't have so much to pay on main gas to be able to use this seamlessly?
Do you mind asking a question another way? I didn't.
I mean, how in terms of future
Yes.
for emerging market like Africa,
Yes.
for early devs who
Yes.
are not in your level to be able to easily play with this particular technology that you just discussing here?
Are you asking like what would be the advantages of having this
yes.
curve implemented for emerging markets?
Yes.
I think it's just a universal thing, right? Like, so if we're able to log in to, like, what's your bank account in Ghana? What's the name of your bank account?
Well, I hardly go to bank now. I use crypto. I use
Exactly. Okay. So, like, for example, if like you're able to log in with your ENS to your bank account, it might be more easy to access versus just using crypto.
Awesome. Thank you. I mean, guys, let's give a hand of applause for Marcus.
Thanks.
Wow, it's getting interesting. We have our next speaker coming up with interesting topic again, and his name is Suya. Please, how do I pronounce your name? Please, join me here. I don't want to murder you. Come. Your name? How do I pronounce your name? Help me pronounce your name, please. Su Yao, right? Suyan. So Suyan is going to talk to us about a mobile-based light client solution. I love this topic, so please help me welcome Suyao on stage.
Hi, good morning, everyone, and so glad to be here. And today, I would like to share about our current work, named Mobi, a mobile-based light client. I'm Suyuan Han, and partner of the ABC Labs. So ABC is not just a venture capital. We are always make our hand dirty before we make the investment. So that's a part of the investment strategy. So this work is powered by the ABC and CISIC. CISIC is another company which are doing really good job on ZK hardware acceleration. They will help us to build a more efficient stateless light client. So the entire blockchain community is founded on one core principle. Don't trust, verify. This principle serves as a foundation pillar for the architecture of the blockchain networks. So after the POS, so the Ethereum officially posted their light client works, but fortunately, several third-party teams are initiating their own implementations, such as Nimbus, based on NIM, and Lodestar, based on the TypeScript, and Helios, based on the Rust. So however, none of the light client solutions can natively run on the most ubiquitous devices, the mobile phone, right? And so our goal is quite simple. We are working on to offer to Ethereum community alternative. A light client can run on any mobile devices. So the motivation. So why this is technically feasible? So as 2024, the performance of the edge devices has advanced significantly. We are already seeing some developers running local LM on your mobiles. And running a light client on the mobiles only require a periodically network communication and some storage. So therefore, running an Ethereum light client on the mobile is entirely feasible. So how to make it happen? So our goal is not build something new, and we want to build a SDK for the native running light client for the mobile platform, especially for the Androids. So we don't want to build something already happened. So the whole architecture is based on the very efficient library called Helios, created by XXD. And Helios is based on Rust, and what we are doing here is to make a Kotlin wrap and to make it as a library for the Android. So our secondary goal is after achieving the compatible with the Ethereum mainnet, and is to make a hub function like to offer light client services for all Ethereum layer 2s if they provided light client protocol. And so because their time is limited, and we'll share some experience to make it happen. So as we know, the Helios is code base written in the Rust. So they're containing a significant amount of their synchronized thread. But Android is on that hand is built on their Kotlin and with running on the JVM. So the Rust do not have their garbage collection mechanisms, whereas their JVM has the GC. So this happened a lot of times that results in the synchronized thread has been incorrectly garbage collected by the JVM. So it's really painful. And moreover, so Android, you have some unique permission protection mechanisms, including the various permission across the arrows when directly involve some Helios code base. And eventually, we have some long ambitions. So apart from the basic functionality, we have further expectation for the mobile light client, including but not limited to the following two directions. The first one is functionality. The core function of the light client is verification, right? But however, given the storage performance of the modern devices, we aim to build something called Light Client Plus. So beyond the simple verification, we intended to add some storage compatibility. For example, users could selectively store some state and historical data of themselves, and then they can query them locally. And additionally, we want to build some RPCs functionality for other light client nodes. It's kind of the portal network. And another part is the entertainment, or make it more smart. As we mentioned, so in addition to the light client, the mobile devices now have the ability to run local LLM inference. So for example, Android private local Gemini inference APIs. And we want to explore where we can combine the local node and the local LLM together to conduct something interesting. And so here is a demo. And I bring my phone here, but due to the time limitation, if you got interesting, I can show you after this talk. And another demo is called local LM, and I bring the Llama 3 billion to the phones, and I can show them after the talk. So that's all. And about myself, I'm partner of the VC Labs and final year PhD at QST, and my interest about the database and everything else. So thank you.
All right, thank you, Suyao. Do we have questions for our friend, amazing speaker here? Okay.
Hi there, thank you. This is great that you're working on like clients in the ecosystem.
Yeah.
How long does it take for the client to be connected to the network? And then how quick can you, for example, do an ETH call and validate that if you build a mobile application on top? And how secure is that at the end? Maybe you can talk to that.
So actually, the Ethereum protocol provided a native function called getProof. And you can use the getProof to verify the data from the other client. So the Helios, basically the Helios works that you can verify any data from untrusted RPCs in a local way because the protocol cannot be changed. So that's really how to guarantee the security.
Yeah, no, I understand that I'm in the same boat as you, but if you do an ETH call, right, which you want to do a method call.
Yeah.
You don't know if the VM that is on the remote side is executing correctly. So do you have a local VM, or like how do you solve that problem?
I think the light client do not have the local VM. They just use their getProof to verify the correctness of their Merkle tree.
Yeah, but with the getProof, you can only prove the storage, not the result of a call.
Yes, yes. Oh, that part is that we want to introduce the AI agent part, like we use LLM to detect whether the core is malicious or not, to help. Because actually the functionality of the light client is very limited so far. So we want to extend something new. That's what this mentioned. Yeah.
Next question.
Okay, so since you are working on mobile, right? There's another constraint which is power.
Yeah.
So how's the power consumption on phones running on yours?
You mean
the battery life? Like how did you optimize for it? Or
so actually, we are working on a benchmark, like how many EVM calls can call on current mobile devices. Yeah.
Okay.
A follow-up to the previous question about how ETH call works. So the way how it works is you have a local EVM inside Helios. They use the Revm, and it uses ETH getProof to fetch the code.
Yes.
You can get the code from the state tree,
yes,
put it in, and whenever the EVM needs some storage that it doesn't have available locally, it is another ETH getProof. Like it's a lot of round trips, there is a lot of latency, there are some efforts on the way to improve that, like to make it more compact. But because the Revm runs locally, it means that you can trust the local execution. And later on, if you have seen yesterday's talk from Justin Drake with like the redacted title, in the future, once we have CK snarks that prove the execution, then the server can also do that, and we don't need the local EVM.
Guys, thank you so much. We'll continue this conversation. Meet Suyao backstage, and let's have this conversation going. Our time is up. Thank you. Please help me applaud our big speaker. The next person is going to be Yannick, and Yannick is going to take us through from nanoseconds to decades, the time scale of Ethereum. Wow. Please help me welcome Yannick.
Good morning, everyone. Thank you all for coming, for being here. My name is Yannick, and yeah, so one way to think about Ethereum is as this very big machine that consists of different gears that connect to each other, that drive each other, and that function together to do what Ethereum does. And these gears have different sizes. Some of them are very small, and therefore they spin very fast, and some are very big, and therefore they spin slowly, but therefore they're all the more powerful. And in this talk, for actually no particular reason other than I think it could be fun and an interesting exercise, I want to go through a bunch of these gears, these processes that make Ethereum run, and have a look at how fast they are very quickly. Starting with the slot time, 12 seconds. Every 12 seconds we get a new slot, every 12 seconds we get a new block in Ethereum, kind of the defining time of Ethereum, I would say. And now from there we can go lower. These blocks need to be propagated through the network. That takes about 2 seconds. Another thing we propagate through the network is transactions. They're smaller, they're easier to verify, so they propagate much faster. It takes about 250 milliseconds to do that. Now we reach a boundary. 100 milliseconds is about the network ping time. Two nodes talking to each other, they will always have a latency of this order of magnitude. So if we go lower than that, then we're in this purely local domain of, that only happens on a single node. Everything above that can be network-wide. 100 milliseconds is also the time roughly it takes to execute a block. Of course, some blocks are bigger, they take longer, some are shorter, some are smaller, they are quicker to execute. 2 orders of magnitude smaller, attestation validation takes about 1 millisecond. Attestations are these votes that validators send to agree on what the state of the chain is. And now we're getting into a range of numbers that are very difficult to imagine for humans. 1 millisecond is not a very human timescale. So I would like to compare this to length, which might be easy to think about. If we go back to a slot and imagine that this is the size of a human, then attestation validation would be about the size or the thickness of a human hair. So quite small already, but we will go even smaller. 100 microseconds, roughly time of an average transaction to be executed. Big part of that is the signature check. Of course, we want to make sure that transactions cannot be forged, and that's why we have these cryptographic signatures, and they take a long time compared to a transaction execution to check. But probably the most important cryptographic function in Ethereum and blockchains is hashes. We hash all the time. Whenever we check a signature, whenever we change state, whenever we build a block, we do a hash, and therefore these hashes have to be very fast, and they are 350 nanoseconds. And lastly, kind of the smallest we can go, a single unit of gas. Gas is the unit of measure we use to measure resources. And one of these resources is computational time, CPU time, and 1 unit of gas corresponds to 10 nanoseconds of CPU time. 10 nanoseconds, again, very small to imagine if we go to length scales. That's about the size of a glucose molecule, the most important energy carrier in biological systems such as humans. We can't go lower than this, but now we can go higher, starting again 9 orders of magnitude above this 10 nanoseconds with slot time, 32 slots in a row, 6.4 minutes, an epoch, the time during which each validator gets to submit their vote on the state of the chain. 2 epochs in a row, 12.8 minutes finality period. And that's, in this presentation at least, the longest protocol-defined timescale. Above that, we're talking about humans, we're talking about human coordination. Humans are slower, so they need more time to coordinate. The fastest that I could think about it was emergency response times. Say Ethereum breaks for some reason, how quickly do we get developers online to their machines to look into what's going on? And 30 minutes is kind of the number I came up with, based on a little bit of data. Of course, there's not a lot, fortunately, because nothing major has happened so far. 2 days, about the time it takes to sync a node. Hopefully we can get this down at some point. Maybe using light clients, as we saw before. 2 weeks, the time between the all core devs meetings, the meetings where the core developers talk about the state of the chain and the changes they want to make to it to improve it. 1 year, the time between hard forks. when we actually implement those changes in these intervals. 2 years, the time to include an EIP. So the time between a proposal to implement the chain is proposed and until it's included in a hard fork is about 2 years in the past. 2 years also the time between Devcon, so maybe we'll meet again in 2026. And lastly, Ethereum is 10 years old now, and the most long-term features of Ethereum, like proof of stake and sharding, have been discussed since the very beginning, and these long-term features can take 10 years to implement. And now, originally I wanted to stop there, but for fun, I just wanted to add another number, maybe 100 years. Maybe that could be the lifetime of Ethereum, if we think about, if we compare to other protocols like email or social systems, then 100 years is kind of the time scale we have to think about here. And if we look at these numbers, we should be very careful what we actually implement here, because it will hopefully affect a lot of generations after us to come. So yeah, maybe that's the only outcome of this talk as well, to maybe make you think a little bit about these longer time scales. Thank you.
Thank you. Yannick, we have questions for you. So guys, do you have questions for Yannick? Oh, okay, cool.
You mentioned that the 10 nanoseconds for unit of gas on computation, also the 12 seconds for a block. I don't know if this is a beginner question or a question but I ask, when in the future the CPU power becomes more powerful, do you think will this 12 seconds change to 6 seconds?
Yes and no. I think the 12 seconds are kind of constrained by hardware of computers, but not necessarily by CPU time. I think there's other resources like network latency that are more important here. But of course, if hardware improves and physical capabilities of computers improve, then these 12 seconds can go lower. And also the amount of gas we can spend in a single block can be improved. Right now, the target is, I think, 15 million gas. We can, if CPUs get more powerful, we can maybe increase this. But also there's other resources that are measured in gas, and they also have to be taken into account.
Thanks for the talk. It was really cute. You mentioned lots of different metrics. I wonder which one is the most important to be optimized?
Ooh, interesting. I think not all of these are metrics that should be optimized. I think some timescales are fine if they take longer. I think some timescales probably can't be optimized a lot. Like, for example, I think the all-core devs meetings, it would be very annoying if people would have to go to a meeting every day or something like this. So, but in general, I think the 2 years improvement proposals, that sounds like a very long time. On the other hand, if we compare it to the 100 years of lifetime of Ethereum, then maybe that's not too bad. So I don't have a clear answer to that. I guess the easiest answer would be like the technical timescales, like reducing block propagation times or things like this. But I think none of these are very crucial, to be honest.
All right, thank you so much, Yannick, for this amazing session.
Thank you.
This conversation has not ended. You can meet Yannick and have more technical conversation on this particular theme. Our next speaker is Dr. Leonardo. And Dr. Leonardo is going to take us through another interesting journey from the long-term decentralized storage for blocks. Dr. Leonardo is an interesting candidate to do this, and he's going to be EIP 444. So help me welcome Dr. Leonardo on stage.
Thank you. So good morning, everyone. Thank you for being here. I'm Leo. I'm a researcher with Codex and also from Mega Labs. And today, I'm going to talk about decentralized storage for blobs. Actually, it's very nice that we have this talk by Yannick taking us through time. And now I'm going to take you through space. So this is, the timeline of the Ethereum history. So we have the Genesis block that occurred in July 30 of 2015. Then we have the merge about 7 years later, happened in 2022. During that time, we had something in the order of 15.5 million blocks. And if you put all of those together, that takes about 427 gigabytes of space. Then in 2024, March 2024, we had the blobs, the beginning of the blob, the EIP 4844. And so between these two dates, we had something in the order of 3-point-something million blocks. And then since March until now, so about 7 months ago, we have been generating blocks with blobs all the time, right? And in these last 7 months, we have generated more data than in the first 7 years of Ethereum. So that's quite a significant amount of data. And to store the entire history of Ethereum right now, it takes about 1 terabyte. So basically, what I'm trying to say today, if there is something that should remain in your head from this talk, is that storing the entire Ethereum history in every single node of the network is kind of unsustainable. And there are several things that are being developed. So one is the portal network, but there is also other ideas, and I want to show one of those in this talk. So there are some files that have been proposed that are called ERA files. An ERA file is a file that stores about exactly 8,192 blocks, the state, and also some index data. Basically, one ERA file is about 27 hours, and it takes between 500 and 600 megabytes of space. So this format has been proposed by Jacek from the IFT. And the PandaOps team, specifically Pari, took all that data from the pre-merge, so it's about 15.5 million blocks, and put it on BitTorrent. So this is the size of the data during those first 7 years. Please notice that we have the blocks are between 50 to 100 kilobytes toward the end of that period. Now, if you look between what happens after the merge, the size of the block starts increasing significantly, and we reach almost 200 kilobytes in average for the blocks. So during that time, we have about almost 4 million blocks. And if you take all those blocks together, that is about 98 gigabytes of data. And there has been this proposal again by the PandaOps team to create like a beacon chain checkpoint sync endpoint where you can actually checkpoint sync your client directly from off-network sources. So you don't need to get all the blocks from the peer-to-peer network. You get all the blocks from a specific off-chain, off-network source. And now, if you look at the blocks after the blobs, basically, there is a new proposal now. It's called the ERB files, which are specifically for storing blobs. And there's no state on those files, but there is the KCG commitments included as well. And you can see that during this time, the size of the blocks have decreased. Because now we're going down to almost 50 kilobytes in size. And so this is, again, a proposal by the Nimbus team, and I think this is a great idea. And what we are trying to do now in Codex is to store this history from Ethereum in Codex. So Codex is a decentralized storage that is protected with the erasure coding, with very reliable CK technology, and we are storing the entire history of Ethereum in Codex. So that's basically all I wanted to present today. And if you are interested, well, you can come to talk to us offline or in the Nimbus booth as well. Thank you.
Thank you. Question time. I love this part of the session, question time. So who's going first? Oh, wow. No question for Dr. Leonardo? Oh, wow. You're a good teacher. Are you a professor?
Sorry?
Are you a professor?
Yeah, I work at the university, yes.
Oh, no wonder. So your students are saying, no question for you, right? Oh, one question. Who? Can I see you? Who? Who is good? No question? No question. No question. Okay. So, Doctor, it seems you gave such an awesome presentation. And what do you tell Dr. Leonardo? Doctor, thank you. Help me. Welcome and say thank you to Dr. Leonardo. Yeah, so we are going to have just 5-minute break. You can stretch your legs. You can do some yoga exercises, whatever you want to do, 5 minutes, and we are back with the only female in this session. Amazing lady. he's going to share with us something interesting. So 5 minutes break, stretch your legs, and let's come back to continue. Welcome back. And how do you feel? Energized? How do you feel? Awesome. So this next session, we're going to engage with an amazing builder. She's passionate about cryptography. And she's going to engage us with something that I'm so interested because we believe that Ethereum and blockchain is much more needed in the frontier market where I come from. So understanding how this thing is going to help the world, especially frontier market like Africa, Latin America is super important and cool. So ladies and gentlemen, and everyone, help me welcome Teresa. She's going to take us through what you didn't know about contract deployments. Sound very interesting, right? So help me welcome Teresa on the team, what you didn't know about contract deployment.
Hi, everyone. Good morning. My name is Teresa. I am a smart contract auditor at Chain Security. And today I'll talk about things you didn't know about contract deployment. So I suppose many of you have deployed a smart contract at some point. And this session aims to take a behind-the-scenes look at what happens at this process. So as a short recap, these are the 3 ways to deploy, to initiate smart contract deployment on Ethereum. So either via the creation transaction or the create or create2 opcodes. All of these will trigger the EVM to execute the init code. So it will trigger constructor execution. Now the question becomes, what if we want to deploy a contract at an address of an already existing account? Can we do that? And for that, we must understand what it means for a contract, for an account to exist. So let's recap that every account holds a state. We have a state that contains 4 fields: the nonce, the balance, the storage root, and the code hash. And for account existence, let's go all the way back to EIP 161 that specifies prior to the execution of the init code, the nonce is incremented by 1. So this means for an address with a non-zero nonce, we can say an account exists at that address. All right, but what does this mean? What are the implications on contract deployment? Can we deploy at an address with non-zero nonce or non-zero code hash? Well, we can't. There's EIP 684 that will revert if you try to initiate creation at an address with non-zero nonce and non-zero code hash. What about the storage? Do we need to care about the storage root? Interestingly, yes, there's also a check on that. And this has more of a historic flavor. There are still a few contracts on mainnet that have 0 nonce, 0 code hash, but non-zero storage. And these are from before EIP 161 that I just mentioned on the previous slides. All right, and what about the balance? Can we create at an address with non-zero balance? Yes, yes, we can. And then that number of way is just owned by the address. All right. Now, during contract construction, there's quite a specific behavior of the EVM. So usually, when you measure the code size of a contract from within a contract and externally, it should give you the same size, the same byte length. Interestingly, during deployment, during contract construction, this does not hold. So measuring the code size from within and from externally will give you different values. And this is an important detail to know. And one important aspect I would also want to shed light on is the values Xcode hash can take. And this is specifically important if you do EOA checks using Xcode hash. You must know what states you can be in and what values Xcode hash can take. So for an empty account, so to recap, Xcode hash returns the code hash of the address you query. So for an empty account, that will be the value on the top right, the 0 byte string. Now, if we deploy successfully to an empty address, This will just take any value, the hash of the code deployed. All right, now how can we get from the 0 address from an empty account to the hash of the empty string? This is if you just send ETH to a random address where no contract lives, Xcode hash will return the hash of the empty string, and also during contract construction, this will be returned. Then from this value, you can of course then create on this contract, because the nonce is still at this account, at this address, sorry, because the nonce is still set to 0, so you can create on that. Now, I want to finish off by asking if this is the complete picture. And in the interest of time, I'm taking this away for you. Well, no. You can still after Cancun, this still holds, so you must not rely when you do an EOA check that once you get the result of a random byte string, that this will hold. Because within the same transaction, contract state can still be deleted. Yeah, so don't let yourself be deceived by the return value of Xcode hash. So in summary, we've seen that for account existence, the nonce is incremented, and this is done before constructor execution. We learned that you cannot create on existing accounts or on EOAs. And there exists still some legacy contracts with non-zero storage, but 0 nonce and 0 code. And for the Xcode hash transitions, I really encourage you to try it out yourself. We set up this Remix workspace, and where you can measure the output of the opcodes and yeah, play around with that to really understand the transitions. Thank you very much for your attention, and if you want to reach out to us, I'm happy to chat after this talk, and you can also do so via the platforms. Thank you.
Thank you, Teresa. Question time, the one I love the most. Who is going first? Question for, oh, okay. I'll try.
Yeah, so how would this EOA checks transform after the EIP 7702, where they implement the auth opcode, and then EOAs can also have ext code hash?
I'm not sure, could you specify which EIP?
The 7702, the auth opcode EIP, where we can delegate EOAs to contracts.
I see. I'm not entirely sure about that, but what is important for now during, after the Cancun upgrade, is that within the same transaction, well, you can have a creation and then you can have any function execution and then still the self-destruct. And that is, I think, for right now, what is often left out of sight is that, yeah, it's still the same transaction and a self-destruct can still occur.
Last question? One more question? No more question? Oh, okay. Teresa, thank you so much. Please help thank Teresa for the session. You can still meet her behind the scene and engage with her. The next speaker is Dominic, and Dominic is going to take us through what is hot, what's not hot, 2024, EVM chat 2024, what is hot and what is not hot. Well, I don't know which one is hot and which one is not hot. To help us understand this, Dominic will lead us into it. Thank you. Please welcome Dominic on stage.
Hello everyone, good morning. Welcome to this presentation. We're gonna see some statistics about the Ethereum EVM. Especially, we're gonna compare some data. We collected data from 100,000 blocks before last Devcon and 100,000 blocks before this Devcon. We're gonna see what changed. I'm Dominic Bridge, one of the lead auditors and co-founders at Chain Security. So, let's dive right in. But first, I have a question to you. What do you think is the most popular opcode used in the EVM? It's push 1. It's mainly used to push small constants onto the stack. Next is push 2, It's for larger constants, and this one is especially used to push jump targets onto the stack. Third in row is jump test. This marks jump test in EVM code. You might wonder why we don't see the jump instruction itself being used heavily. And this is due to in the EVM, we have two instructions to jump and jump I for the conditional jump. And both together roughly add up to the same number as jump test. Overall, between the data sets of Devcon before the Devcon Bogota and before this Devcon, we see no change in the most popular opcodes. Moving on to the least popular opcodes. Least popular opcode is call code. This is basically a less helpful variant of delegate call, and it's used really few times only. Log0 just emits log events with 0 topics, and invalid opcodes, they basically simply consume all the gas of the current context when they are called. Now, prior to Devcon 7, this changed slightly. Create made it onto the list. It became less popular. Invalid is still on the list. This one is slightly interesting, as this is one of the opcode that is dominated by one single contract. The invalid opcodes are almost exclusively used by the USDT contract. They have an assert in a Cipherpunk library they use, which produces an invalid opcode if triggered. Now, especially for the least popular opcode, it may be interesting to discuss some opcodes that do not appear on the list, particularly self-destruct. Since the Cancun hard fork, this opcode has basically become obsolete. Let's ignore some special corner cases here. It now simply transfers all the ether of the account onwards. Investigating this, we were surprised that the opcode is still used for in some cases. And yeah, even more interestingly, we saw that there are still gas tokens deploying new contracts. We don't know why this is still done. We think it's due to legacy code still being triggered by some contracts. Let's have a quick look at the new opcodes introduced since last Devcon. Keep in mind that all contracts deployed before this opcode were introduced won't use them. So all execution you see here must be from recently deployed contracts. Push 0 is already used for 0.7 of all opcode we've seen. So this new opcode is already used more than, for example, call data load or mul. You might wonder why tstore is used more than tload, because in a typical reentrancy pattern, you have tstore, tload, tstore. Now, what about precompiles? Prior to Devcon 6, ECCs was by far the most heavily used precompile. It was mainly used by OpenSea's Seaport contract for signature verification. Keep in mind that we only have 11 million EVM transactions in our data set, so 2 million users is quite a lot. For SHA-2 the heaviest user was the ETH2 deposit contract, and identity, which is mainly used in Viper for memory operations. Now, before Devcon 7, we see way less EC recover operation. The 4 heaviest users now are Permit2 and Wormhole contract. For SHA-2 the heaviest users are the ETH2 deposit contract and Eigenlayer. And we saw that Viper's popularity rose, and we see this reflected in the identity opcode. Yeah, the least popular opcode, interesting here, it's one single contract that does all the Blake 2 calls. Transaction complexity, the numbers of calls per transaction went down while the memory consumption decreased. Yeah. So super quick summary, push 0 is super hot, EC recover is used less, and there are more calls per transaction. We've prepared a blog post which is not fully ready yet, but will be published soon. It will have full description of the data, more plots, more results. Thank you.
Thank you, Dominic, for the short presentation, insightful one, of course. Do you have questions for Dominic? Oh, okay. Let me try.
Hi. Yes. Yeah. It's interesting to see how create was one of the least opcodes. Do you have a reason or thesis as to why that is the case?
I'm pretty sure because create 2 became more common, and then the statistics are split, right?
Right, yeah, okay. Cool, thanks.
Next question. Okay.
What can we do with all these new findings?
I think it's important for the core devs and the people discussing the EIP's stuff, especially for the opcodes. It's really good for them to see, right, that push 2, a new addition, they recently introduced, is really used heavily and has an impact. And they can take a look at the statistic and see what isn't used so heavily. But of course, it's hard to deprecate something, right, because we still have contracts relying on them.
Thank you.
Last question? Okay. Thank you, Dominic, for the session. Please give him a hand of applause. Oh, wow. It's interesting to be within the technical guys. I'm kind of, wow. The next session? Break. Yeah. Okay, so we do a quick break and come back at 11:20. So just 3 minutes break to stretch. It's going to be more intense. So 3 minutes break, back 11:20, and we continue. Just stretch. Welcome back, guys. It's been interesting. The next speaker is going to take us through something interesting. And he called himself a newcomer in Ethereum, and he's a mathematical nerd. I ran away first year in mathematics class, so I didn't do maths. I don't know anything about mathematics. And we have an amazing person to walk us through this important topic. Welcome, Elia. He's going to take us through how copying memory from EVM, how hard can that be? We could have gotten an amazing person than Elia, who is a mathematical nerd. Please help me welcome him on stage.
Hi everyone, am I audible? I think so, yeah. Good to see you. I'm Elian Suoni. I also work at Chain Security. I can guarantee this was not on purpose. We didn't bribe the organizers. It was so nice of them. My topic for today is arguably the best fit for a lightning talk, because it turns out it's not that hard to copy memory in the EVM, especially since Cancun. But yeah, we'll see exactly how much. So, the right way to think about it, in my opinion, is before Cancun and after Cancun, because since Cancun, we have a new opcode that does exactly that, and it's arguably the best way to do it. But before then, you had to implement this some other way, and there were two main ways to do that, to copy from memory to memory in the EVM. So one was to do an mload plus mstore loop. So you would do 32 bytes at a time. You would load 32 bytes from memory onto the stack and store it back from the stack to the destination in memory. And this used to be, well, quite heavy in terms of code size because it's a full loop. And it also had quite a bad gas cost in terms of gas cost per memory word copied. The alternative was calling the identity recompile that we just saw with the last presentation. And while that has a little less code size because it's just a static call that you can do to the contract, still, the gas per memory word is good enough. It's only 3 gas per memory word that you copy. But the overhead is quite big because you have to do a call. So it's at least, I think it's 180. Yeah, we'll see later. Anyway, since Cancun, all our problems are solved because we have a new opcode that does exactly that. It has the least code size because it's just one opcode, the least amount of gas. So now there's no reason not to use it. And as I'll tell you, it's very much widespread now. So let's just go quickly over some numbers. One way to implement the mload mstore loop is in software. This is done in a quite popular yet a bit old Solidity library. And because it's done in high-level Solidity rather than entirely in assembly, then you see you have 2 checked additions, a checked subtraction, all this done for every memory word that you copy, which adds up to a gas cost of around 286 gas per memory word copied, which is quite bad. Then we have the same concept but implemented entirely in assembly, which is what the Solidity compiler will auto-generate for you. It's a function. If you inspect the IR, it's called copy memory to memory with cleanup, I think. And yeah, it's a tighter loop, so it has less overhead. So overall, the cost per memory word copied is only 67 gas. And the code size is also much smaller. Then, just to see an example of how the identity recompile would be used, it's used by a CFORT library, and also it's what Viper used to generate to copy memory to memory before Cancun. And yeah, the cost per word is the best. It's just 3 words, 3 gas, but the overhead, the constant term, as you can see, is quite big because you have to make a static call that has also a fixed cost of 15 inside, and then you have to do some checks. So it's not ideal for small copies. Now keep in mind that we're neglecting the memory expansion cost because that'll be the same whichever method you opt for. And also, we're doing this comparison right now with these opcode pricing, but keep in mind that those have changed and will change again in the future. So whatever conclusion on which method might be the most convenient now maybe wasn't the same. You wouldn't have come to the same conclusion 5 years ago, for example. But yeah, just to be sure about it, now the mcopy opcode is used by both Solidity and Viper for Cancun contracts. And the gas cost is the least, the code size is the least, so everything is good, the future is bright. I didn't have the time to add the slides to this, but from the same analysis that Dominic and the other colleagues at Chain Security did, it turns out that already now the mcopy opcode is already used more than the identity precompile, even though it's only new. It's only quite new since Cancun. So it shows that, I mean, I don't know exactly how to phrase it. Maybe there's a lot of new contracts deployed that already outnumber the number of, I guess, Solidity Viper contracts for legacy. So yeah, it's quite popular already. Then yeah, I've prepared a remix setup for you, and also if you want to shoot a message to our sales representative to get an audit, which is never a bad idea, feel free to do so. Yeah, I'll take any questions.
Thank you for the session. Please, do you have questions? Oh, wow. You have a lot today. I'll try.
Hello.
Hello.
You said that the memory expansion cost is the same in all three cases.
Yeah.
But my concern is that with the loop option, if the memory you are copying is not a multiple of 32, not only you may copy memory you don't need to copy, so that's more expansion, but also you may override something that is outside of your destination, like just after your destination.
Yeah, so the memory expansion cost is actually, I'm only 87% sure about this, but it's only computed on the number of memory words rounded up. So even if you end up writing at most 31 bytes, you don't incur memory expansion cost for another word. So it is the same even if you overwrite within the same word that you've already paid for. Then, what was your other question? For overlapping, yeah. If in some of those functions are specified for cases where the overlap is okay, for example, in the Yule one, because I think that one is only used to allocate at the tip of the memory, so there's nothing afterwards. But in cases where that's not okay, for example, the library, they do special tricks, like they round it up with an M store that's aligned to the last byte that you want to write to, and the rest they mask it with the content that's already there. So you're basically writing back what's already there on the part that overlaps, and on just on the new part, say the 20 bytes, you'll write the new stuff.
One more question for Elias. Okay, no question? I'm curious, Elias. So as a non-technical person, being among almost everybody's technical here, how do you communicate to a novice like me to be able to kind of comprehend in simple language?
I think I have a knack for it. Like, it just comes natural to me. Like, for me, I don't think I've understood something until I can explain it to my mom. So I guess that's
all right. Thank you so much, guys. Sure. Let's give him a hand of applause. Wow. Staying with technical guys for like 5 hours already. My blood is hot. The next speaker is a researcher and a developer, and he's going to walk us through a team, programmable, cryptography, and smart contract development. Everyone, help me welcome Shuki on stage. Thank you.
Hi, everyone. Thank you for being here. So today I'm talking about my current research, program cryptography and smart contract. So program cryptography is more flexible than traditional cryptography styles like RSA. So this time I'm talking about how to run smart contract based on off-chain execution by ZKP and secure computing. At first, let's talk about ZKP and smart contract. So it is easy to integrate with smart contract because we have a solidity verifier which enable to produce a verifier contract. So we can verify the ZKP on chain and transfer the asset to any other approver or something like that. And so we can combine with ZKP and FHE and MPC and produce a verifiable computation. I will talking about this later. Yeah, so this section, I want talking about how to integrate with FHE and smart contract. The basic principle of FHE is encrypted evaluation. And only who can decrypt is just client. So it is difficult to integrate with smart contract by default. If we using smart contract, we need to share the encrypt result and also decryption key by client side. But it does not make sense to achieve the secure computing, right? But somehow we have a solution to combine with ZKP or MPC. So verifiable FHE is a kind of technique to prove the FHE's evaluation, and we can verify it on chain. As I mentioned before, we can use a solidity verifier. And match key FHE is a little bit different concept. It's split the decryption key and share it to the third party, like a smart contract, whatever. Both of two stuff is so cool, but somehow it is difficult to integrate to smart contract on top of the proof of time and the data problem. Okay, so next section is how to integrate MPC and smart contract. The concept of MPC is evaluate collaboratively. So each party share own bits of confidential data and collaboratively evaluate it and compose it to get the result. So in this time, we don't integrate with smart contract. However, I think you can imagine how to solve this problem. You know, we can combine with ZKP or FHE like that. So verifiable MPC is similar concept of verifiable FHE. So we can prove the execution of MPC and verify it by smart contract using a solidity verifier. Also, collaborative snack is similar to verify with MPC because we combine the ZKP and MPC, but this is different from, in terms of collaborative snacks, this is just generate proof collaboratively. So user able to delegate the proving to MPC. Okay, so let's wrap up my session. I introduced how to run the smart contract by off-chain execution of programmable cryptography. Main idea is using the solidity verifier and on-chain verification. Also, we can combine with each primitives to overcome the con of some primitives. So programmable cryptography is so cool, and we can empower the Ethereum and the blockchain technology as well. And I think it is, we need to more try to some issue, as I mentioned before, like a proving time or a dealer's problem. Yeah, that's it. Thank you.
Thank you, Shoki, for the session. Do you have questions for our speaker? No question? Oh, good. Sorry, I forgot my volleyball lessons.
Yeah, I wanted to understand what other implementations are there, like any use cases or example where FHE.
Yeah, one of the verifiable FHE's use case is kind of evaluation of stats, like off-chain stats, like a bank account or a GPA or something like that, I think.
Next question. Okay. Next question? Okay. All right. Since there's no more question, I'd love to give some break. You know, when the classroom is tense like this, you need to allow people to have some time. So please, you can get up, stretch your legs, do some little yoga exercise. Just 2 minutes, and we are back. At exactly 11. welcome back. We have 2 more for this morning session, and the next speaker is going to take us through an interesting topic again. Help me welcome Rim, who is going to speak on Verifier Alliance, inside of the contract verification pipeline. These are all technical jargons, right? So, ladies and gentlemen, everyone help me welcome Rim on stage.
Well, hello everyone. My name is Rim. I'm a software engineer at BlockScout, and which is an open source block explorer. And today I want to invite you to try to verify a couple of contracts along with me. Let's start with answering the question, what the contract verification is. When you deploy the contract onto the chain, it is represented as a number of bytes which Ethereum virtual machine can understand and execute. And there are no solidity or hyper sources stored inside the blockchain. So when indexers index the contract data, all we can see are those 2 bytecode values, which are contract creation code and contract runtime or deployed codes. But most of the people are not good in understanding the raw sequence of bytes, and what we usually want to see what is represented in the picture below. So we ask our developers to send those sources to us, and we recompile them and check that those actually correspond to the on-chain code values. And this is the contract verification. And today I want to verify a couple of contracts with you. So let's start with the simple one. Represented by those 2 code values here. What do we need from the user to verify the contract? First of all, we need the source files themselves, of course, and let's assume that this tricky storage contract is our potential candidate. It is tricky just because it adds some magic number before storing it inside the storage. That's it. Also, we need the compiler version, which the contract has been compiled with, and the compilation settings. With all that information, our next first step is just to combine all of that into the standard JSON input format, which has all information just in one file. We submit this JSON to the compiler, and what it returns us back is the standard JSON output, which is quite big usually, but what is important here for us is that it returns 2 bytecode values, compiled creation and compiled runtime code values. So what we have to do here is to just take those 2 bytecodes and compare them. Do they match? Yep, they matches, so that's it. Actually, is it always that easy to verify the contracts? Well, let's look at a little bit more complex example here, which is where we used as external library for making the addition operation, and external libraries as the contract codes, which are deployed once at some address, and when our contracts can link their addresses inside themselves and reuse their functions by delegate call opcode. So we'll do the same transformations as before, and we'll get 2 bytecodes as well. But do they match? Well, we can see that there is a strange, not even a hex part inside the compiled creation code, which does not correspond to the on-chain value. So why it happens? Actually, this is the place where the library address should be put at, but as we haven't provided it to the compiler during the compilation, it just don't know what to put inside, and places some placeholder instead. So, and our question is how to verify such contracts. Luckily for us, there is a special section inside the standard JSON output, which is named link references, and which for each unlinked library contains some information how to where this library address should be placed inside, especially the first byte where it should be placed at, and its length, which is always 20 bytes. So what we need to do is just to take the specified offset value, when take the next 20 bytes from the on-chain code and substitute it inside the compiled code. So do those 2 byte code match now? Yes, we do, luckily for us. So here we are, just verified the second contract for today. In general, such replacements, we name them code transformations, and those are some actions which may be applied to the compiled code before or after, during the deployment process, and which changes its bytecode a little bit, but which remains the functionality the same. And there are currently 5 of such transformations we know about and support. And we've talked about the libraries, but there are 4 more we don't have time to talk about today. But if you are interested, you might just follow the QR link and see some more information about. So also, I think the last slide, my presentation title was Verify Alliance, the first part of it. And I haven't talked about that a lot, but if you are interested in that part as well, you are welcome to the panel, which will take place today at 5:30 p.m., where Blockscout, Sourcefy, and RoadScan, the members of this Verify Alliance initiative, will describe you this a little bit more and talk about verification as well. Thank you. I think that's it.
Thank you, Rem. Do we have questions for Rem? Oh, okay.
Is this a mic too? This is pretty awesome, actually. Why is it so difficult to have decentralized contract verification, right? We use services like Blockscout, Etherscan, but why, after all these years, is the experience still so bad in general?
Well, I think it happens a lot because you have to store this contract somewhere, first of all, and there is Sourcefy which tries to decentralize the storage process itself. And but actually, what is more important here, there are a lot of different formats, and all different explorers use their own formats to store this data inside. Sourcefy uses its own data, and one of this Verify Alliance initiative's idea was to develop the schema in which all contracts should be stored at. And with that, actually, we are going to have just one database of all verified contracts shared between different verification providers. And I hope that will help to increase the decentralization of this data. So we're going to share some bucket dumps for that, opens access to the database maybe, and hopefully that will work.
All right.
Thank you.
Shoot.
Okay. In the verification part for contracts that use library, looks like we are using the reference bytecode from the deploy bytecode. Is that safe?
Yes, that is safe because after the compilation, we've seen that with 20 bytes, that the library address was assumed to be put inside those 20 bytes by the contract code itself, and this address can be anything actually, so we just take the actual value. So we assume that the on-chain code is should also contain the library address at this place and take it as our address. So it's actually safe, just because this offset was in the standard JSON output section.
All right. Thank you so much for this session. Please help me appreciate our amazing speaker, Rem. So, too soon, we are about to end my session. And the last speaker is going to talk about something that I'm super interested in, and because I've had some experience in the past. So the next speaker is Richard, and Richard is going to speak on Firefly. Build your own hardware wallets. Help me welcome Richard.
Hi, testing. Can you hear me? So, a lot of you probably know me from, my slides are excellent. Most people probably know me from Ethers.js, but today I'll be talking to you about Firefly, our new exciting hardware wallet that we want to get in the hands of everyone. So, keep me on my time. I see all the things. Okay, so what do we have? So what is Firefly? So Firefly, it's an open source firmware, open hardware wallet. It's going to be cost effective. Hopefully everyone will get them for free. We have like 126 to give out today, so feel free to drop by after and grab one. And it's customizable. You can do whatever you want with it. If you want to like start your own Firefly competitor and just take our hardware and our software, you can run with it. If you can produce this cheaper than us, we welcome you to. The goal is to get security in the hands of people everywhere, no matter what. And so if you have a more cost-effective or a better way to disseminate to a group of people we can't reach, we want that. So again, it's about making hardware wallets fun again, whether you want to put a game on it, whether you want it to be like a little animated GIF thing, Pong. If you have a CryptoKitty you really like and you just want like a hardware wallet that's just dedicated to that CryptoKitty only forever, you can do it. So assembly. Originally this was going to be a like 2-hour like assembly thing. So if you want to build your own, you're starting your own empire for Firefly, you're trying to take us out, first thing you need is a crew. So my parents and my wife over here, we got together, and in an evening, I mean, it took about an hour and a half, and I think we made 200 Firefly. So, I mean, my parents aren't super technical, and they can build these things. I actually have one here I was going to build on stage, but I think I will forgo that just because I'm running out of hands. Things you need basically a pile system. You need like a pile of like the panelized boards. So 6 Fireflies come per board. This is all in a script in the repository. If you want a single PCB board, you can do it and just have one Firefly per board. If you've got like a crazy manufacturing facility and you want like a kilometer square of these things, you can just type those numbers in and, I mean, power to you. So you have a pile for like your completed Fireflies, your displays, the cases, and that's really it. It just like clips together. Again, it's designed to be nice and simple. We're trying to like reduce costs to make it easier to do what you want to do. Right, so step 1, I just cover this. You depanel it, it just snaps off. And there you go, there's your Firefly. Then you clip your little screen in. I'm not going to do that right now. Again, lack of hands. And it snaps in. It's like a snap fit, so it has a nice satisfying click once it all works. Okay, so that's assembling. Provisioning, so this is where you might, if you were trying to like compete with us, do your own thing. So we have a private key that we use to sign each device. So the device generates the private key for attestation on the device. It's never been on any computer ever. It also is why it takes like 2 minutes to provision a device sometimes. RSA is kind of crazy. You basically pick a bunch of random numbers, do some rudimentary math to make sure it's not obviously not co-prime. And then you burn that to the chip, and first it sends that to a signing server, which signs it. It's a bunch of like back and forth, but at the end of the day, you get like proof on the device, evidence on the device that it can use to prove that it's a genuine device. So if you're trying to build your own CryptoKitty empire that each CryptoKitty lives on a device, now the device can prove to the world, I am a genuine device issued by Axiom Zen, and I have not been tampered with. And cost breakdown, just for those that are curious. I mean, the costs are there. You can take a look at it. The big cost for us right now is the case, which is 3D printed. I mean, we're doing low runs of like 500 at a time, so that's a huge cost right now. But once we move to injection molded, you can imagine that goes down to like 12 cents. That's like $2 off of the cost. So we get down from $9 to 10. Canada has a lot of extra tariffs, so there's another like $1 we're paying. So anyways, there's places to save money, and we're trying to bring the cost down. Yes, and huge thanks to ENS DAO, Public Goods Working Group. Their funding helped us with the first 2,000 devices, and so we're like 650 out of those 2,000. So the next event will have another 1,000, and that is my talk. And I have 10 seconds left, but I think there is time allotted for questions. So.
Yes. Thank you, Richard. We got our first. Thank you.
Hello. how can you ensure that each of the devices are unique and no duplicates have been made?
Duplicates in what sense?
In their baked-in private key.
So the private key is generated using like thermal noise on the device. During the provisioning process, we also jam it full of extra entropy. And so it mixes the entropy we give it, and it takes its own entropy and smushes them together to like make, I mean, we could produce fraudulent devices, but that attestation key is more of a threat to us if someone else gets it. But there's a digital signing peripheral on the device that makes sure that private keys, encryption key is all stored, and the CPU can't reach it. Like, even if you write your own firmware, which you're more than welcome to do, you can't ever get that private key off. Like, we can't, so.
Thank you.
Next. Okay.
Thank you. This is amazing. If someone was to try to dedicate some time to hack either the firmware or the hardware stack, where should we start?
Please come see me. We will be. I'm hoping to get a bounty out for. I exactly want to pay people to try hacking it.
Awesome.
I want you to like, if you think you found a way to like glitch the device or undervolt it. The devices are currently based on the ESP32C3 version Rev 0.4. So the glitching issue that affected the previous ESPs is not currently known to affect this. But if you can do it, I mean, A, we would love it, and B, I'm sure Espressif would love to talk to you as well because
Sounds good. Thank you.
Yeah. Sorry. Yes. Oh, sorry. I was just being reminded off stage to check out the Twitter because it's at Firefly Pocket. Because that will, I should have put that on the slides, because that will be a good place for you to kind of track all the crazy things we're working on. And if we post a bounty, that's where it'll be. Sorry, I cut someone off that was asking.
Okay. Oh, yeah. I have a question when it compares to other hardware wallets, right? Like, there seems to be a dominant player called Ledger. How do you compare to that? How would you help us sell Firefly to the users of Ledger and make them convinced we should all use Firefly now?
So in that regard, I mean, I feel like there's still space for all these players out there. That we're not trying to conquer the world. The goal is not market share. The goal is just, I mean, providing that competition that maybe makes them do a different thing better. Or there's definitely, yeah, we're not trying to conquer the world. But one huge focus we are dedicated to is A, we're Ethereum first, basically Ethereum only. I mean, Ethereum adjacent only. Obviously, like your Arbitrage and all that work. But we don't focus on Bitcoin or those other things. And so a huge part of Ethereum is really meaningful, clear signing. Like we don't want, the word blind signing should never occur on your device unless you're calling a method in a contract called blind sign, in which case it's a terrible name, don't call your project like that. So yes, that's the big thing we're aiming for is like, yeah, death to blind signing.
Last question? Okay.
Yeah, not quite a question. I actually just want to say, thank you for Ethers.js.
Oh,
You've made Ethereum accessible.
Thanks. I'll be talking about Ethers on Friday if you're around and want to hear some hidden gems for the API. But yes,
Amazing.
Thank you.
And then so to see you do another project like this that makes signing accessible, and it's amazing. So thank you.
Awesome. Thanks.
Last question. All right, thank you guys. And Richard, thank you so much for this. Let's give a hand of applause to Richard. Wow, all too soon. Thank you very much for being an amazing audience. We are coming back at exactly 10:01. My name is Eric, and I'm building the human layer. As developers, you need to build with a human being in front. So let's talk about the human layer we are building in Africa for this ecosystem. Thank you. See you again.
afternoon. My name is Fred. I will be your host for the rest of the day. I hope you had a great lunch break. So this afternoon we're going to have a very interesting discussion. We're going to cover mainly 3 tracks. The first one is going to be real-world Ethereum. So that will bring us to 2 o'clock roughly. And then we're going to discuss crypto economics. That will bring us to 5 p.m. And we'll finish the day with a discussion around Cipherpunk and privacy. This day will be comprised of lightning talks, so it will be very fast. So we won't be able to use the Meerkat application that you've been using in other rooms. We'll just use the time-proven method of raising your hands and talking once we have the mic. We'll start immediately with the first speaker. This is Mrs. Georgia Rakusen. She has a high expertise in the world of Web3 UX and customer discovery. She's previously worked with the big names like Solana Labs and NIA Foundations, and she's now a senior staff UX researcher at MetaMask. And she's now going to talk about building for the next billion, product validation tactics. Please give a warm welcome to Mrs. Georgia Rakusen.
Hello, Devcon. Hi. It's awesome to be here. Nice to see everybody. So I'm Georgia. I'm a lead researcher at MetaMask. I'm also co-founder at OpenUX. I'm here today to share some hands-on tactics on getting your product widely adopted. So throughout this presentation, I'm going to pretend that I am an imaginary Web3 product, but the story for this product is pretty common. Let's imagine we're just some generic DeFi protocol with some 1,000 or so daily active users, and we offer reasonable interest rates on stablecoins. Our core audience is already adopted Web3 users, but we haven't grown substantially in the last bull run. So we know that earning interest on savings is like a universal use case, but how do we reach all those users who are not already adopted? Here's a typical adoption curve. You're probably familiar, this will be familiar to you. So you'll have heard the term crossing the chasm. Why does a chasm exist at all? Because the majority always has a different reason for using your product compared to your early adopters. They use it in a different way and they value different things from it. So to cross the chasm from early adopters to majority, we need to understand these folks and what it's going to take for them to adopt my product. So the first thing I'm going to do is look outside of our own community and identify watering holes. So these are online places where people talk about their problem and how they solve it with other users. So I put myself in the mind of the majority user, and I'm going to come up with 10 to 15 search terms that they might use to solve the problem of earning a decent interest rate on their savings. So here's a few I came up with. And I go online and I use these search terms. I put myself in the shoes of this user and follow the rabbit hole. So I go outside of the usual places to find this information, away from crypto, Twitter, Telegram, Discord. So the point is finding new users, not not there in your own community. So yeah, I'm looking all around the web. These 2 screenshots here are from mountain climbing and car enthusiast forums with users talking about savings accounts and crypto. So I'm looking for the language they use, listening to their fears and pains, how they solve their problem in real life, what they value from different services, and coming away from this activity, I now know whether the problem is really big enough to warrant a solution, and also what novel marketing channels I could utilize if I needed to. So when it comes to pitches, your landing page is doing a lot of work, right? My imaginary product has a landing page already. It might work for early adopters, but now I've learned something about the majority user, how they describe their problems and pains. I can create a whole new experience for them. So I come up with lots of different versions of our message, but tailored with this new information, right? Not like this. It's going to look something like this. And I find people to talk to who fit my ideal user profile, but they don't know what my product is. And I test these pitches, right? So I'm going to try 5 or more versions, all very rough, nothing fancy. And I asked them these questions on screen about each pitch, right? In your own words, what do you think this is? What already exists that does something like this? What might you be able to do differently if you had this? Imagine you tried it and it sucked. What went wrong? And after asking these questions, I'm listening for what questions they have, what excites them, what turns them off. And coming away from this activity, I now know what value proposition most resonates with the majority user and what else I need to be doing to allay their fears and uncertainties so they'll try us out. My last tactic I'll share with you in this very brief talk is about testing the most important moments for users that will signify whether they will adopt your product or not. So the two most important factors for adoption are the acquisition moment, that's when a user chooses to try your product over others, and the retention indicator, that's when the user derives value from it. It's the novel moment, it's the wow factor when they go, I made a good choice here, right? So I'm not going to rebuild every part of my product experience and then put it out into the world to find that it's just not needed or wanted by the majority. I'm not even going to prototype every part of the flow and test it. I'm just going to prototype these two most important moments and test them with real users. So I mock these up really rough in a Figma flow, right? The acquisition flow might look like a tweet or a blog post, going to a comparison site, then my landing page. And from this, I can learn what I need to do to position my product in a way that will mean that majority users decide to choose it over the competition. And in my imaginary DeFi product, our wow moment might be when a user sees how easy it is to deposit funds, or it might be when they realize how much daily interest they can earn. So I'll test these wow moments, right? And I'm doing this really scrappy. If the user gets excited by this, even though I'm embarrassed to show them this stuff, then it means that I'm onto something. So coming away from this activity, I now know, does the way we position the product compel people to try it out? And does our core value proposition, our differentiator, matter enough for people to use it? I might not like the answer I get, but much better to know that now, and I can iterate on this and find where the real value proposition is. So lastly, I'll just say some of what I've shared today is humbly appropriated from Tom Kerwin's Innovation Tactics from PipDex. I recommend you check it out. I'm not paid to plug this, but I use it in my work and it's really, really useful. So definitely check it out and come and talk to myself and other researchers, designers, and marketers at the Adoption Hub today. So let's up our game, make tactical plays, and think outside the box. Thank you.
Thank you very much. So now we'll have time for a few questions. So as I said, we're not going to use the app. I'm going to throw the mic at you. Raise your hand if you have any question. Questions? Nope. Nobody wants the mic. No question? Okay. Well, thank you very much.
Thank you.
So give a nice round of applause to Mrs. Georgia Rakusen. One question?
Hello.
What? I can't see. Oh, yeah.
In the middle. Whoa.
Sorry.
When you were testing on a bunch of users, where did you get the users you were testing on? Or
the age-old, where do you recruit users from? Come and talk to us at the Adoption Hub. There's loads of routes for finding users. Definitely pitch your research as user research, not as sales. Come and talk to us at the Adoption Hub. We can talk about that, for sure.
Thank you very much. So yeah, give a round of applause to the speaker. So our next speaker is going to be James Vore, is the founder of Firefly. contract engineer at Open Zeppelin Contracts. He also has experience with infrastructure, given his past experience at Open Zeppelin Defender. And he's going to talk about how to onboard 22 million users overnight using non-conventional cryptography. Please give a warm welcome to Ernesto Garcia.
All right, everyone, how's it going? Are you enjoying Devcon? Great. So let's get into it. This is a quick presentation, so we better go quick. Let's start by the agenda. We're going to cover 3 topics today. The number 1 is a quick refresher on Web 2 cryptography, because this is important for what we're going to talk about. Number 2, the Mexican case for digital signatures. I'm Mexican, so I want to share more a bit about this specific use case. And number 3, what is the status of this very similar use case around the world in other countries? Let's get into it. And let's start with this refresher on Web 2 cryptography. For understanding this, we're going to explore public key infrastructure. Who's familiar with this topic? Okay, I see some hands. Perfect. Let's go into it. So basically, public key infrastructure works by having a certification authority, right? This certification authority can certify that a certain private key, either for encryption or signature, is belonging to someone, right? For example, we can use this to issue a certificate for a website. If you have seen the green lock before, that is basically what it's doing. It can also enable machines and, of course, individuals. But what is interesting is that we can also enable more certification authorities, which at the same time can enable more certificates for, again, websites, machines, and individuals. All right. So the most common use case of this is basically using the certificate for encrypting the communication for a website. If you are putting a password on certain website, this is probably encrypted by using one of these certificates. All right, now that this is clear, let's get into some particular use case using government certified credentials, because most countries already use some sort of regulation for certifying private keys for digital signatures. So what can we do about this, and how can we use it to onboard 22 million people? Let's take a look. For those who don't know, basically there is a model law published by the United Nations in 2001. This is for electronic commerce, and if you have ever used your credit card on a certain website, it's basically according to these regulations. In this one, it is specified that governments should issue a certificate for a private key for individuals. So in reality, even before Bitcoin was invented, some governments were already trying to onboard people to use crypto for digital commerce, all right? So the important thing is that the talk is called How to Onboard 22 Million People, but in reality, on these couple of months before I submitted a presentation until today, there has been around 3 million more people certified by the Mexican government to use a private key. And these certificates are tracked by some public data that you can also find. I don't have the source here, but I can definitely share it with you. So as you can see, there are 24 million people, like individual people, and around 2 million businesses who already have a private key that is certified by the government and already has KYC, so we don't have to ask them for a passport or a digital ID or something like that. They literally have a private key we can use and put into an account, like using account abstraction, and onboard people immediately to that. So the way this works is, in Mexico at least, the Bank of Mexico, which is the main authority, certifies the taxes authorities, right? By having this structure of intermediary certification authorities, more private organizations can issue digital signatures for individuals. Like this, literally all my family and even my aunt understand how to manage this private key. So these people already understood how to do basic private key management, revocation, and these kind of things, like recovery, as we all do. All right, so this is the interface to generate your private key. As you can see, this is pretty familiar. This is basically telling you to move the mouse. Who's familiar with that? To create entropy, right? This is run locally, so that means that the account is completely self-sovereign, even that the government is certifying it. Because you only share the public key. You have your private key for your own, and you can use this for any legal purpose in Mexico, at least. So just a quick meme. Not everyone is really happy with that, because there are some privacy issues related to this. But we're definitely getting there. At the end of the day, people is already certifying their own private keys, sharing their passport or some other way of identity. So what's the status for this around the world? All of these countries have some way of public key infrastructure that can be already used for enabling people to use crypto and crypto services. Most of this is already regulated, so if you were looking for regulation, there it is, guys. Some other cases, like for example, if you're from Spain, in Spain you have this small ID with a little chip on that. That chip includes another private key, and the only issue with this is that these are RSA keys, which is not recommended anymore but by the NSA on the following years, but we can definitely change that, right? So aside from instead of this, we have been scanning some of these codes and making a CK proof and adding some trust assumption to the process. So my call to action for you guys is just use the cryptography. It's already there. Thank you so much.
Thank you for this interesting talk.
Yeah, any question?
Do you have any question? Okay. Try.
Right.
So whenever you generate a private key and you use, entropy, and then like a developer, you are trying to secure these SSH keys, how does it work from the consumer's endpoint in the Mexican case? How do you store and secure those private keys?
You store them locally. Usually, if you go to the office, they ask you to have a USB, which is obviously not the best case. But the problem is that I think nobody has brought these questions up, right? So the more we ask questions about it, the better we get. Right now, it's just an USB.
So if you happen to lose your USB, you have to do the process again?
Okay. Yeah, but you can do it online. You just need to basically tell the authority to revoke the certificate. There is a Merkle tree who has all of the public keys enabled or disabled. So you just put it on a revocation list, generate another one, certify it again, you're good to go.
Next question is over there.
Yeah. There is a security issue in ERC-20 standard, which was classified as the lack of transaction handling. This issue caused $150 million losses since 2017. In 2023, the author of ERC-20 standard, the Fabian Vogelsteiner, confirmed that ERC-20 lack of transaction handling is a security issue. This was reported to Open Zeppelin 3 times, but you didn't apply any fixes to your implementation of ERC-20 token. Why? Why is this issue not documented in your GitHub repository and causing financial damage to your users?
Okay, I think there is an issue for that. It's open, so everyone is pretty welcome to contribute. I think there is not much contribution on that, so that would be my answer. Thanks.
Okay, any more questions? One over there.
Hey, what would you say is the main impact of the adoption of private keys for everyone in Mexico? I mean, not everyone, but so many people.
Yeah, I guess the main impact is for tax purposes. That's what it's used for, and that's why people don't really like them, right? But basically, you can use it for legal documents, and there is some regulation that specifies how to transfer digital assets. I mean, it's not called digital assets exactly. There is some sort of legal framework, but basically, you can put real-world assets fully compliantly using these keys.
Thank you very much. That was the last question. Thank you very much. Thank you.
Thanks.
So our next speaker is Mrs. Karen Scarborough. She's the executive director at the Enterprise Ethereum Alliance, as well as a senior technical program manager at Microsoft. And she's trying to drive collaboration between the industry and the Ethereum ecosystem. And today she's going to talk about EEA and the institutional Infinity Garden. Please welcome Mrs. Karen Scarborough.
Great. Very happy to be here, everyone. Once again, I'm Karen Scarborough. I lead the Enterprise Ethereum Alliance's executive director right now. And in my day job, I work for Microsoft. So I have a very good hand on how some of the largest enterprises are viewing Ethereum today and what can be done to increase Ethereum adoption and awareness in the community. So I definitely think it's worth it to go over what exactly is the Enterprise Ethereum Alliance. And if you haven't heard about us before, we were actually an organization started way back in 2017. At that time, a lot of enterprise use cases were going on private blockchains. There was a number of standards and technical specifications that needed to be developed in the industry. And Ethereum actually put together the largest consortiums of companies to be able to start acting on that activity. So we are a nonprofit, membership-based organization that is advocating for the adoption of Ethereum in business. And ultimately, our goal is to make it so clear for business that whenever they choose to do business in Web3, Ethereum and the Layer 2 ecosystem is the very clear choice that they choose to go with for where they'd like to build, invest their time, use cases, etc. So core parts of what we do, we host events throughout the year. That's been one thing that has been a huge pickup this year. We want to be right alongside the Ethereum community, so you'll see us out at ETH Denver, ECC. We had a major event here this Monday with our EEA Industry Day that I'll talk about a little more, Token 2049, and certainly online and on various digital communities as well. We also have technical specification groups and interest groups. So a key group that we do have is our DeFi Risk Assessment, Management, and Accounting group that published a set of risk guidelines for enterprise this year that's been looked at not only by enterprise, but also governments around the world. And we had over 15 enterprise companies collaborating with Web3 companies, putting that together. We have our cross-chain interoperability group that also issued their specification this year and has had implementation as well among different use cases in enterprise. And to get into a little bit about the renewed momentum that we have, because we started in 2017, but just like a lot of blockchain projects, going through the trajectory of what's moved from different technologies over the year. We certainly had a lot of interest in private blockchains in 2017. Now it is 100% public Ethereum base. That is our recommendation and our strong point of view to the enterprise ecosystem is to choose public Ethereum for where you want to build. We had new leadership come in this year, myself, Paul Brody from Ernst & Young that works very intimately with the Ethereum community on the whole with the enterprise privacy solutions that EY is building. And at the beginning of the year, we set out to regain this momentum that we had in 2017. And at the conclusion of this year at this event, I think we've largely achieved what we've set out to do and include lots of plans on what to do for the next year as well. So I mentioned some of the things our groups have done, the events we've participated in, and the #1 mission that we do have is fostering this community to improve Ethereum adoption in industry. So why would organizations want to be a part of EEA? Our membership rate is increasing at an all-time high at this point. We have super high quality members, not only the likes of Microsoft, EY, JP Morgan, Santander on the Web2 side, but we also have Circle, Karpathy, Gateway, ENS also joining as well from the Web3 side. If you're a Web3 engineering team that wants to come to enterprise, join us because we're going to give you the largest spotlight possible to connect you with the right people. You'll see the pictures on the side from our Industry Day event this year, which we highlighted a lot of Web3 companies doing work with enterprise that is very significant and throughout a lot of different brand names. And you can see we brought out 300 people plus to that event with 75 plus speakers. So it was a very well attended, heavy content event that we plan to do more of in the coming years. And we have strongly articulated points of view. We are not coming in with, well, maybe choose this ecosystem, maybe choose that. We are Ethereum based and want to give clarity to the enterprise ecosystem to join us in doing that. So if you want to learn more, I have some QR codes up here about our membership and our website. And thank you for the time here.
Thank you very much for your speech. We have time for a few questions. Raise your hand if you have any question. I can't see with the lights. One here.
What a catch. Thank you. Hello. Working for Microsoft, a question I have is, what do you think their intentions are with Ethereum? We see EY launching products or trying to build products in that space. What is your take on Microsoft?
It's where we want to build. I'll put it that way. It's the strongest ecosystem to align with for the future of the technology, also surrounded by the largest ecosystem as well. Agnostic of any technology, we want to be aligned in that which is being the most successful, that which is solving customer problems, and aligned with where the future is. So more prolifically, if you look at enterprise cloud environments, Ethereum has always been the basis of which to build there. And that's really significant. There's not other L1s that have the one-click deployment for enterprise developers to build on, and thankfully Ethereum has that. We should have a lot more. The more that you can meet enterprises where they build, the better.
Thank you. We have another question over there.
Yeah, I guess it's an extension of the previous question. With people like Microsoft and EY building components in the space, like Aztec is a privacy-preserving layer 2, and I know EY is doing privacy things on mainnet Ethereum. Are they sort of on equal footing, or is there some advantage to, say, EY being able to incorporate things a little closer or recommend things for enterprise? And I guess a similar follow-up question is, when you say Ethereum, are you talking like just mainnet Ethereum, or are you talking Ethereum including layer 2?
So first, tackle the second question here, the Ethereum layer 2 ecosystem. So we're not directing people to mainnet activities, but building in that which has Ethereum as the settlement layer of the internet. And then in terms of your other question on how do we evaluate which companies to go with, a good thought there is we want to align with projects that have sustainability, support, and a clear future roadmap. So that is something to think about for enterprise, because once something gets in production, which not a whole lot of enterprise proof of concepts get to at this point, there's a release team, a maintenance team, there's a security team that all have to be in place to make sure that that product continues going for enterprise. And that's really significant. So the more that Ethereum-based Web3 ecosystem projects can support that, the better. Because a lot of times, I would say, tech is very important, the innovation behind it, et cetera. But at the end of the day, if you can't support the longevity of a product in an enterprise environment, that's going to be an Achilles heel. So.
Thank you. So we have one last question over here.
Sorry, I have a controversial question here. So what Microsoft did with OpenAI, taking open source, putting into closed source, do you think it will align with the open source ethos, what Ethereum is built upon? And do you think like they will start acquiring startups, building cool tech, and making them closed source?
Well, the way Ethereum and this community is structured, I don't think we could be successful even if we wanted to choose an alternative direction. I think the entire success of what Ethereum has built and cryptocurrency in general is reliant on an open ecosystem. So I'm really encouraged by that. Our open source position is pretty strong. There's certainly different business models that can be successful around that, and we're keen to explore that.
Well, thank you very much, Karen. Please give a nice round of applause to Karen. Thank you. So our next speaker is Mr. Mike Silagadze. He's the founder and CEO of Ether.fi. And prior to that, he was the founder and CEO of Top Hat. He's an active angel investor and mentor in the startup community. And today he's going to discuss what DeFi founder can learn from Web 2. Please welcome Mr. Mike Silagadze.
Hello.
All right, so this is going to be a quick one. So I'll try to go fast, but hopefully keep it comprehensible. So yeah, my name is Mike Seligadze. I'm founder and CEO of Etherfi. And my lens on the crypto space is that I come from a Web 2 background. And so one of the things that I want to talk about is what are some of the lessons that Web 3 founders can learn from the Web 2 universe. So just to give you a little bit about my background, I got into crypto super early, bought some Bitcoin back in 2011. That's like the actual confirmation email. It was about $1 per Bitcoin at that time. There weren't even exchanges. I had to just PayPal some money to a random guy on an internet forum, which was fun. Then around the same time, I started a company called Top Hat, which was a Web 2 company in B2B SaaS. So specifically, we were doing education software for universities, which is a very challenging market to be in. Spent about 10 years growing that company. It ended up being pretty successful. We got it up to around 450 employees, about 65 million revenue, and then sold it in 2021. It was a great outcome. And so then I decided to do pretty much the exact opposite as far as you can get from education software, which was my first passion, crypto, and started Etherfi around 2022. And that's gone remarkably well. We've been humbled at all our success. We're the #4 DeFi protocol by TVL, at least about 8 billion in TVL given current ETH price. Yeah, around 30 million revenue and growing super fast. Couldn't be more excited about it. One of the reasons I would say that Etherfi has been successful is because we've taken sort of the discipline and mechanics of operation of the business and brought it to the DeFi world. And so what I want to do is just talk about, what are some of those lessons. So, the curse of crypto is that there's way too much money in the space. There's just a ton of gambling money coming from the great, casinos in the sky. And that actually, the effect that ends up having is crowding out real product development because it basically eliminates the need in many cases for getting product market fit. If you're doing, a Web 2, more traditional SaaS type of business, the cycle of that business looks roughly like this. You acquire a customer, you get the customer to give you dollars, you then keep that customer by providing a good service, then you reinvest that back into R&D, and then the customer is happy, and there's a nice positive feedback loop. In Web 3, it looks a little bit different. Usually, you find a project that's really cool, maybe a nice DEX, you launch a token, you vest your tokens, you cash out, and then you're done. It's a great business model, super easy to make really, shocking amounts of money doing it that way. But when the main business model is basically printing casino chips and then taking a rake, this is why we can't have nice things. So what I'd like to do is talk about what are some of the principles that you can use to construct projects that actually have some sustainability. And the reason they're important is because there's actually, I guess what I would say is almost a science around this stuff that goes into putting together these businesses that are sustainable so that you can answer this question, is your project a viable project? Does it have some sustainability, or is or a Ponzi? Okay, so here's some quick definitions. So we're going to run through this really fast. CAC is cost of customer acquisition, or customer acquisition cost. ARPU is average revenue per user. Churn is basically how much you retain, one cohort of customers to the next time period. Net dollar retention is how many dollars you're retaining from one time period to another. LTV is lifetime value. So these are kind of like the key. I mean, there's probably dozens of other metrics, but these are the key ones that you need to remember. And the main question is, are you even measuring these? Because if you're not even measuring these things, you're probably more in or you're lending yourself more to being in the Ponzi camp. Okay, so what does this look like? Well, this is the fundamental kind of mechanic of customer acquisition. You spend a bunch of money. Let's say you spend $5,000 to acquire a customer. And then every month you get a little bit of money from that customer. Maybe it's a DEX, you spend some money to acquire them, sales and marketing, BD, whatever. And then the user trades and that generates revenue for the project over some period of time until the customer churns at some point. And so at some point, you go from negative, let's say you spend $5,000 to acquire the customer, and then the customer pays themselves back. over time, you go to cash flow positive, and then ideally, if you at some point pay back the cost of acquisition, the project actually makes sense. So the rough benchmark is that your LTV divided by your CAC needs to be greater than 3. Why? There's lots of reasons for that, but to be a top quartile kind of company, you want to make sure that your lifetime value of your customer is worth more than 3x the cost to acquire that customer. And you want to make sure that the payback period is less than 12 months. That matters because it has a dramatic impact on the growth of your business. If your payback period is like 24 months, you're basically never going to get out of the trough. The business isn't going to work. Whereas otherwise, you get a really nice growth graph. Okay, I'm over time. So the other thing that matters is churn. You want to make sure that you're growing your customer base. The cohort of customers that you have is growing in terms of their usage of the product faster than the customers that you're losing, the customers that are churning out. If you have high churn, you basically plateau because the cohorts all kind of compress and go to 0. If you have a negative churn, then it grows really nicely. Okay, so the first step I would say is, in summary, you got to measure these things. If you don't know these numbers, then you're going to have a bad time. And there's a real science to this. So I encourage you to go out there and research about how this science is put together so that you can build more sustainable projects that have utility. Thank you.
Thank you, Mike. So we have time for a few questions. Yep, it's a bit far. Can I? Over there, behind you.
Thank you. What's your most valuable customer acquisition channel?
I think for most projects, I mean, it's X or Twitter. That just, that tends to drive most customer acquisition. And then word of mouth. There's in the SaaS world, there's a parameter called the K factor. How many customers does each customer refer? So I think in crypto, it's pretty much Twitter and word of mouth.
Hey, love the presentation. Thank you for the pricing strategy 101 reminder. That was great. As a double founder in Web 2 and Web 3, what's your take on the fact that the majority of the people in crypto come from like successful companies, successful business school? We majority all know this, but collectively we are not able to do the basics to deliver insightful projects. I'd love to hear your take on that.
Yeah, I mean, I guess just to, so first of all, I would say the operating chops in crypto are pretty low. I mean, just being honest, the average founder that you meet in crypto tends to not have very strong operating chops. Huge amount of money wasted without really any consideration for ROI. Companies just, they're not run super efficiently. And so you see projects that are, even some of the largest projects in crypto that should be just absolutely printing money, that are instead just hemorrhaging money incomprehensibly. A complete lack of financial literacy, people that think token emissions are revenue and other insanity. So I don't know. I mean, maybe it's because it's just so easy to make money by doing the Ponzi stuff versus doing the hard work. Okay, I can talk more about that, but I'll stop there.
Thank you very much. So please, oh, sorry, we don't have more time for questions. So thank you very much for your time and for this interesting talk. So our next speaker is Marc Pascal. He's the founder of the Wellbeing Protocol. And so he's been running the first university course in the world on the AO. He's been founding Blockchain Labs. He's been a partner at Metacartel Venture, and today he's going to discuss the Wellbeing Protocol scaling localism. Please welcome Mr. Marc Pascal.
Hello, can you hear me? So my name's Marc Pascal. So for the last few years, we've been thinking about a problem that was really well described in this book called The Third Pillar. Raghuram was the ex-head of the Indian Reserve Bank, ex-chief economist at the IMF, And the way he describes the problem is that society is supported by 3 pillars. We've got the free market capitalism company pillar, then we've got the state government pillar, and we've got community pillar. And what's happened is we've had a few revolutions. We've had the agricultural, industrial, technological revolution, and they have fundamentally shifted the power. They've moved the power towards the big corporates, the company pillar, the government pillar, and the community pillar has suffered. And he argues that this shift in power has fundamentally caused some of the most systemic problems we've got in society today. So from the environmental breakdown to loneliness to inequality. So what can we do to correct this problem? Because it's really hard to take away the power from the people who've got it on the 2 sort of very powerful pillars. So what we can do is empower community. And I guess we've been reflecting for a little while and asking ourselves the question, could decentralization help to bring back community? Is there a way to do this? We went down a whole lot of rabbit holes over the last few years, exploring not only Web3, but a whole lot of other tangential things. And we kind of emerged in this point where we started to imagine if we could, if a small, hyper-local, informal group in a marginalized community could spin up a micro-collective, micro-foundation, a micro-DAO, as easily as a Facebook group. And imagine if that user experience and the support network around that made it super easy for that group to make decisions about money. And imagine if we could scale that 100 times, 1,000 times, 1,000,000 times. And imagine if we could also make it super easy for funders to stream money into those micro treasuries. And by funders, we mean anybody with a kid with $10 through to a multi-million-dollar DAO. Could we catalyze this network of decentralized grassroots change makers with this mechanism? So we got a really exciting opportunity last year to take a first step towards that vision. We got funding from the New Zealand government to work with an indigenous community to actually start to reimagine the community grant system. So this community was a Maori men's health group. This is a picture of some of the lads here. That's me and my co-founder and some of the ladies who represented the funders. And really our brief was to reimagine the grant funding system to create one that supported and empowered the group, the men, to solve their own problems. Long story short, we got more funding from 3 other government agencies. We built some software. We ran a trial. Went really well last year. And we're now running trials across New Zealand, Australia, and the UK. And we picked up some pretty cool supporters along the way. So Aya she personally funded one of our trials in New Zealand and has been a great support for the project. So what have we actually built? We were really inspired by an article by Jeff Emmett, who is maybe even here. He presented yesterday. So he's been a real OG in this space, and this article he wrote a few years ago gave us a lot to think about. But what we decided to do was to really try and take some of these quite complex governance mechanisms and to focus on the user experience. How do we turn this into something that real people can use? So what have we actually built? I'd love to spend half an hour showing you the app. It's an app you can download from the app stores. But what and I haven't got time to show it, so here's some of the key things. So we build in fund streaming, conviction voting, quadratic voting, dynamic thresholds, workflow, delegated voting, all sorts of cool stuff. So so it's out, and we're running a bunch of trials across the world using it. So what next? So I think the really exciting thing is that once you've solved a trust and engagement problem, you have a foundation to build some other really exciting stuff on top of that. So micro endowments, volunteer coordination tools, savings pools, all that sort of stuff. We get 100% voter turnout. We get 100% engagement. Come join us. We're looking for funders. We're looking for partners to roll out more trials across the world. And yeah, if you want to have a play afterwards, just in the top right-hand corner, download the app, search for Hum Community, request to join the Ross Reserve community, and you can do some quadratic voting. Thank you very much.
Thank you. So, are there any questions? Yep. Questions? Yeah, over there.
Hey, thank you. Any deep-in projects has been experimented on?
No.
Yeah, hi.
Hi.
It was an enlightening session. So the thing what I would like to understand is, when you have certain of these ideologies, for example, like effective altruism, which could, which is termed as beneficial to all, but over course of time it get diluted and we see, bad things happening in their ecosystems. How do we make sure that, the essence of what we are trying to achieve using protocol is not eventually getting diluted, and how do we prevent the bad actors getting into the thing?
That's a difficult one. What we've done is we've experimented with building something where we can create a new mechanism to stream money. The big picture is we want to create our own DAO and embed the values of the DAO into doing good, and ultimately decentralize our governance to the communities that we're supporting. So, yeah, I think it being taken over by bad actors, that's something that we are very conscious of, and we'll, do everything we can to make sure that doesn't happen. But I think we're quite centralized at the moment. We're going to, obviously, becoming a DAO is a journey. We're early on that journey. So.
Yep. So the question I had was that, is there a rollout plan for involving some of the developing nations as well?
We're sort of, as I say, on a journey. We've been talking to people in Uganda, Africa, and it's really about building out that network. I guess one key point I would like to make is for the marginalized communities, technology is just one small part of the solution. We need partners, on-the-ground partners, to work with those communities. And there are organizations already out there. There are community development organizations, charities. So we partner with a bunch of those in the UK and Australia already. We need to connect with more of those in developing nations so they can work with the communities, and effectively we support those organizations to run trials and grow it out from there. But, yeah.
Question over there.
So what did your Maori users decide to do with your fund?
They did a whole bunch of things. Again, the interesting thing was, so the whole thing is held together with constitutions. That's a document that the community make that really defines the purpose of the fund and what they're going to do with it. That's pre-agreed, and the funder agrees to that constitution and essentially agrees to keep streaming money in if the community adheres to that constitution. The first trial, the Māori Men's Health Group, Tāne Ora, the funder agreed to a more holistic view of health. So in Māori, we have a thing called Te Whara Tapawha, which is a more holistic view of health, and the funder agreed to that. So the guys, they organised trips to the beach, they bought sports equipment, they paid for nutritionists to come in, they did a whole bunch of things, but it was very much their decision, and they come up with all sorts of ideas. So yeah.
Sorry, that was our last question. Thank you very much for your presentation. Please give a nice round of applause to Mark. So that was the last talk for, sorry. So we're going to have a short break, and we're going to come back at 2:50. Thank you. Hello, welcome back. So as mentioned earlier, we're going to touch the second topic, second track of the afternoon, which is going to be crypto economics. So this is the biggest chunk of the afternoon, and we're going to start with the first speaker, who is Lisa J. White Tan. She's the founder of Economics Design and Horus. She's an expert in token economics and DeFi, and a recognized author on the topic, and a guest lecturer at universities all over the world. She's going to talk today about data-driven tokenomics Analyzing incentive in action. Please welcome Mrs. Tan.
Hi, everyone. Good afternoon. Have you guys had a good lunch? Yeah, okay, fantastic. We only have 5 minutes, and then we have 2 minutes for questions, so I'm going to go really, really fast. You're going to pay a lot of attention for 5 minutes. So today we're going to talk a lot about understanding data and how data impacts economics. Who here built economics? Or who here deals with economics? Okay. Who here are founders and cares about economics? And who here are builders? Great. Good. Wow, a very, very even split. So just a TLDR of economics and data. When people think about economics, people usually think about it in a 0 to 1 phase. When I need to launch a token, when I need to launch my project, I need to think about tokens and how tokens interact in the space. And that's where a lot of the focus has been, which rightly so. Things like your modeling, your agent-based simulations, your risk testing, your risk scenario analysis, that's a very, very big portion. At the same time, today I want you to start thinking about how can we use data to start understanding how the protocol has been doing and use data to help improve the health of the protocol. In every project, there are 2 key phases, 0 to 1 and 1 to 100. 0 to 1 is when you're brand new, you're fresh, it's MVP, finding product market fit, going to market. And there you use a lot of economics and to build, it's all theory-based to build out the economics. On the other hand, when it's live, in your 1 to 100, you actually have user feedback, live data, validated data that you could stress test the system and really understand how users behave. So the challenge that I want you guys to start thinking about is how is the data giving us information about how users are interacting with the protocol? The truth is that as much as you're building the economy, you're defining the economy, you're writing out the rules of how this game works. And people are just going to game the system. Whether you like it or not, people are just going to game the system. They're going to find loopholes. They're going to find ways to extract more API, more value. And that's fine. That's normal. In fact, once you launch the project, things are just going to get more and more chaotic. If everything follows the model and everything follows the simulations that were built out, all the economists that I know, they'll be really, really rich. But they're really, economists are quite poor people. So the reality is that it's not like models. It's not like simulation. So you need to be able to balance that. And one way to start thinking about it is using a lot of SaaS metrics, SaaS analytics. Things like average revenue per user, user acquisition, user retention. All these data will be very valuable and insightful to understand how users are behaving and interacting with the protocol. At the end of the day, tokens are just an incentive to get people to behave in a certain way. So once we have the data, we can validate if users are really reacting to these incentives or not. And it's fine. If they're reacting to it, double down. If they're not reacting to it, how do we change? How do we update the rules, update the system? So that's the general gist. Happy to go into more case studies, happy to answer more questions. And I think there'll be time for questions. Do you guys want to raise your hand and see how far I can throw this damn thing? Okay, I'm going to throw it and then you try catching, okay? Hey, good job! All right, go ahead.
Hey everyone, Robbie, went to the XYZ.
Well, actually, you can talk.
Oh, I can talk in this.
Yes.
Oh, that is crazy. I thought that was just a fun exercise we were doing.
Exercise, gotta keep fit.
Yes, I love your videos. I love just everything you do. From your perspective, what has been the most successful tokenomic design in terms of adoption from a data perspective? So I know, for context, you see a lot of tokens, or just protocols use LP incentives, right? But if you look at the data that Uniswap has put out, they typically aren't very sustaining, even though they might cause temporal advancement in terms of what you're trying to achieve. And it seems as though there are not too many sustaining tokenomic designs that actually drive wanted behavior over the long term. So just wanted to know your thoughts on that.
Yes, very good question. And as an economist, the answer is it depends. However, there's context to this. It depends on 2 main factors, your business model and your revenue stream. If your main goal is to get more liquidity in there, and then you need these incentives to bootstrap liquidity, versus you need incentives to keep getting more people to interact with the protocol, these are all different kind of behaviors. At the end of the day, the question you're asking is, what is the best incentive out there? My question to you then is, what is the behavior we're trying to incentivize? Are we trying to incentivize user acquisition, or user retention. Take airdrop, for example, which is a very popular thing, which I am not the biggest fan of, but it's a great distribution mechanism. The pros of that, let's start with pros. Huge user acquisition. However, the cons of that is there is lack of user retention. People are there just for the financial gains. And as I said, when you put the rules of the system out, the rules of the game, people are just here to exploit the system. So, which is fine. Maybe you could start off with user acquisition and some airdrops, but it doesn't need to run for such a long time. Take the data and understand how users are reacting to it. Alternatively, it's point system where you've heard a lot about, and also how do you allocate reputation to different kind of people so that they can, and then we can start allocating it correctly to the right kind of users.
Hi. So thank you for great talk. And my question is more around the social aspects of a platform, right? So tokenomics, it's easy to understand, not easy, but I mean, it's different to understand ROIs and things that are more financial and like one-dimensional. But on social, like I'm from grabber.xyz, and we're trying to optimize social interactions and meaningful social interactions. I wonder if you know some examples of where this comes in and where you saw like remarkable examples of like tokenomics that work with the social aspect.
That's a very good question, because everything that we've been talking about so far is always the quantitative, because quantitative is something that we can measure. Your APYs, your TVLs, all of these are some things we can measure, and once you can measure that, you can always optimize for that. And I really love your perspective, which is social. Social is really hard to quantify, it's really hard to define. And one example will be things like governance or decision-making protocols. So one thing to think about, or one avenue to start considering, is how can we tie in the natural way that people go inclined to, which is financial incentives, tie it with the social aspect. Take Polymarket, for example, right? The biggest case study of this year. How do you use financial incentives as a way to signal preferences? And from there, you can start building very, very complex models and very complex decision-making mechanisms that takes into consideration both the social aspects and the qualitative aspects and the quantitative aspects. I'm happy to go more into details later.
Yeah. We have another question over there.
Thank you very much. So I wanted to follow up to the first question, because you said that different type of activities require different type of incentives, which is, I totally agree with that. So we have analyzed, for example, LTIPP data from Arbitrum, where Arbitrum spent $15 million on incentivizing DeFis and dApps and user acquisition for them. And the thing is that most of those users basically left dApps and DeFis after 3 months, either to move to another program, for example, ZK Sync Ignite, which is pretty similar and is happening right now. I mean, it's work in progress. So basically, we call these users mercenary users. So what are your ideas and thoughts about keeping the, retenting these users, keeping their retention in the ecosystem, and fighting off also mercenary users who basically move from program to program to utilize it for their own profit?
So I'll give you the short answer first, and happy to talk about the long answer after. The short answer is that these things are something we cannot control. This is just natural forces of how the market works. When there is green grass, the sheep will just go there and eat the damn grass. That's just how reality works. There's no point controlling that. It's not possible to control. What we can do is to understand that it's going to exist, and how do we channel the funds or the assets, the resources, to much better resources. So reputation building, understanding like transaction history. Are these people mercenary users, or are they actually value creators? At the end of the day, you are balancing two things. One is value extractor in the short term, and one is value creator in the long run. And what are the different nuances within your business, within the protocol, within the foundation, that help to channel towards the other side of things? So there's an aspect of token. There's also an aspect of business model and revenue stream that you have to balance quite a bit.
That was the last question. Thank you very much for your talk. Please give a nice round of applause to Lisa. So our next speaker is going to be Julian Ma. He's a research scientist at the RIG group, so at the Ethereum Foundation. Using tools from finance and economics, he aims to improve the Ethereum protocol, and today's topic is to start contributing to economic protocol development. Please welcome Mr. Julian Ma.
Hi, everyone. Thank you for the introduction. I'm Julian. I'm a research scientist at the Ethereum Foundation, but 2 years ago, I was a volunteer at DevConnect in Amsterdam. So I'd like to share something that's an insider's perspective on how to start contributing to economic protocol research. So first of all, what does protocol research mean? Well, it means contributing to Ethereum's future, whether this is via decentralization, efficiency, or censorship resistance, using tools from crypto economics to help make decisions. So I think industry research very much is about research as a tool for decision making. And here it means we need to find what are the properties that we want for Ethereum. So these are normative questions, and then answer these with, given these properties, what economic mechanisms are optimal. And here you can see a picture of the Scourge, which is part of Vitalik's roadmap, which is the main part of crypto economic research that we're focusing on now. So where to start? It might seem a bit daunting to read the roadmap, because the roadmap is about all parts of the ecosystem. And then if you continue and you read some other posts, some of them may be a bit too in-depth. I think the best way to start is simply by finding some researchers whose work you really, really like. And often in their post, they'll say something like, these are the limitations of my research, or there is some opportunity for future research here. And then try to identify some way how you can extend upon their research. And then, very importantly, which is very important in crypto, is just contact them with your idea, because everyone is open to find new people. So when you're trying to find a problem, make sure to take into account tractability and innovativeness. So tractability means how well can I answer this question, and innovativeness means how innovative is my answer. And tractability depends on your skill set. If you've been a programmer before, perhaps something is easier that involves a lot of development. Whereas if you're coming from academia, maybe you're better at answering questions of these are the properties that we want and what is the optimal mechanism to use. But also find some trade-off there. So let's say that this is the optimal frontier. Find some problem that should, in principle, be ideal. But then be aware that this is actually very difficult to do. Don't spend too much time looking for the optimal problem. Just get your hands dirty, get familiar with how Ethereum works, and do this by finding some problem that's maybe not on the frontier, but that's at least tractable to your skill set and has a small contribution if possible. It's important to get to know the protocol before you start doing something, because the protocol is very large and very complex. And getting to know all of it first is simply too time-consuming. That being said, I think Ethereum very much has a culture of just come in. Everyone is very open and is actively looking for active contributors who are here for the long term. And I think this is our unique property as an ecosystem. We want to be decentralized. We want to be geographically decentralized, and decentralized in terms of who brings which ideas. So please just come in. So that was my pitch. Thank you very much. If you've heard Justin's talk yesterday about Beam Chain, this will need a lot of new people looking at various different subjects of the Ethereum protocol. So if you feel you're interested and you have some idea of where you can contribute, and your idea is maybe not on the frontier, but it's tractable and it's innovative, then email beam.chain@ethereum.org. Thank you.
So now we have time for some questions. Do you want to? Okay, I can. Are there any questions? Up over there. Watch out for the computer.
Well, one, very much appreciate your time. I just wanted to ask for the spelling of that email real quick.
Let me see if I can go back or no. No, okay, so it's just beam, beam.chain@ethereum.org.
Beam.j.
Beam.chain.
All right.
Any other question? No. We have a bit of time, so over there.
Hello, I'm a researcher from university. And in university, there are some grant to ensure researcher can do their jobs. So if we want to work with someone in Ethereum ecosystem, how can we, make the grant works in the university? Because I think the traditional academic institutions are not accept the Ethereum foundation or something? Yeah.
Okay, yeah, that's a great question. So for how, I can speak a bit to how grants work from Ethereum Foundation and more how they work in the broader ecosystem. So first of all, in the broader ecosystem, there are lots of places willing to give grants. And I think most of them are focused in like this mindset of research for decision making. So there will be some specific question that needs to be answered, and sometimes academic work is a very, very good way to answer this question. Within the Ethereum Foundation, we give out academic grants, and they can be structured as grants or as gifts. If it's incompatible with your university, I'm sure that we can work something out. The application process is usually a bit different, so proposals don't have to be as formal as they are usually in academia. But again, I think the most valuable ones for us are clear, like, that you have some understanding of how the protocol works for your question. So it's clear that the question is tractable, and it's clear what the contribution is. So what is the decision that you're trying to motivate, or what mechanism are you proposing?
Thank you. There's another question in the front.
Thank you for the talk. You use the term economic protocol. Is the same as token economic design, or is different?
I would say the terms that I use in this slide are not set in stone. So we would be open for research in various directions. Yeah, I wouldn't adhere too much to what's like the exact words in the slide. We'll be open to any economic ideas that you have for Ethereum.
Thank you. We have time for one more question. Is there any more questions? No. Okay. Well, thank you very much for your talk. Yeah, no, we still have one. No, this one? So yeah, okay. Okay. 3:10. Okay. So actually, we're going to have a 3-minute break, and we're coming back at 3:10. The next speaker is Terence. He's passionate about open source and has been involved in the Ethereum protocol development since 2018. He's one of the founders of Prism and is focusing on EPBS. Today he's going to talk about exploring auction mechanisms in protocol design. Please welcome Terence.
right, hello. Well, first of all, thank you, Julian, for the wonderful talk. I think it's a nice segue to what I'm going to talk about. So, disclaimer, I am just an engineer. I'm not an economist. I'm not an altcoin theorist. So this is based on my intuition, basically. But yeah, let's see how it goes. So I guess this was originally supposed to be a 20 minutes talk, but at the end we shortened it to 5 minutes. So I'm try to speed run it as fast as possible. But I guess the high level I want to cover is that of the what, how, and why of different altcoin design in protocol today. And I want to make some specific implication of like different protocol within each option. So basically, we'll do some case studies. So today we'll look at layer 1, and then we'll look at layer 2. So for layer 1, we'll look at MEV boost, we'll look at EIP 7732, and then we'll look at EA and ET options. And then on the layer 2 side, we'll look at first come, first serve, PG, and then time boost. So for each category, we'll look at what is being exchanged, like who is facilitating the exchange, and then we'll look at who captures the profit, and then we'll look at when the auction conclude and reveal, right? So for MEV boost is what we know today, right? And then if Alice wants to build a block through Bob, the builder, I have to go through the relayer, and that is the auto protocol trust, and this is what we have today. And then another thing is that it doesn't scale long term because of everyone plays timing game these days. Because of that, this creates further friction for further updates that Pierre does and Fossil. And then moving forwards, that we have EIP 7732, and then this changes the trust assumption. Therefore, you only need to trust the protocol. The protocol guarantees unconditional payment, and it guarantees builder safety. And then even within 7732, there are different designs such as block auction and slot auction, and each of them have like different trade-off. For example, like for block auction, you could have like a DA problem because of the hash gets committed first, but then the 6 seconds it gets revealed, nothing gets revealed. You may have a cancellation problem as well. For example, if the builder commits to something and then the price goes over the water and just doesn't reveal, right? And then slot auction has its own problems. Slot auction's problem such as that, like, you have to trust, if you slot auction, that you may have an advantage by using the relayer, but then at the same time, there probably is less transaction inclusion time. So here are mostly trade-off space that like between 7732 that like it's probably worth thinking more on like the comparison between slot auction and the block auction. Then there is EA and ET. So both EIP 7732 block auction and slot auction consist of like a timing game, which is possible. But then the idea of EA is that instead of like just in time for the slot off, you essentially do the auction that's further ahead of time. This is to reduce timing game. And then for ET, basically, instead of proposer choosing the builder, you have this protocol that essentially issues the tickets. And then because of that, you can enable like MEV burn type of design. But that also opens like concerns about like multi-slot MEV. So finally, like let's jump from layer 1 to layer 2, right? So today, layer 2s, there are even different auction mechanisms, and then most of them are conducted through a centralized sequencer, and that is easy in a way that sequencer is trusted. So you have this private mempool guarantee, and then it's straightforward to reason about. And then you can do this very fast because like users love the UX of like fast confirmation, right? And then who collects the profit? Typically, it's the company that's operating the sequencer, or it's the DAO. Depends on how like decentralized the like basically how decentralized the layer 2 is. And then within different like auction of layer 2, there are first come first serve, there are PGA, and there are time boosts. And then basically like within each auction, there are implications on how it affects developers, dApps, and stuff like that, and UX. So I guess like the takeaway here is that like the auction design is like such a like fascinating space. It's such a profound space. It basically relies engineers to work closely with mechanism designer, with like game theorists, with the economists, and many more. So yeah, if anyone is interested in this type of design, like please talk to Rick, please talk to like people, and yeah, thank you.
Thank you very much. So now for a few questions, please raise your hand if you have any question. No question? Okay, well, thank you very much. Yeah, so the next talk has been canceled, so we're going to be back at 3:30. back. So the next lecture is the next speaker, is Christopher Schlegel. He's a researcher at Flashbot. He's an expert in game theory and mechanism design. And today he's going to talk about Sybil proof mechanism. Please welcome Mr. Christopher Schlegel.
Here we go. I wanted to pitch my favorite theorem of 2024 in mechanism design, very subjective. That's joint work with our brilliant intern in Flashbots, Ming Hao and Akaki over there. And I want to also tell you a bit about how it relates to Ethereum roadmap stuff like PBS and so on. So here's a question. Have you ever wondered, can we have a decentralized builder market under any mechanism that we can use to select a proposer or builder? And how can we make this question more precise? So how can we think about it from first principles? And we wanted to turn it into a mechanism design questions. So we are wondering, okay, could we have an allocation mechanism to select a proposer that proposes blocks? And we operate in a permissionless system, so we worry a lot about Sybils, right? And we want to be distributed or decentralized. We don't always want to select the same proposer, okay? That's minimal requirement for decentralization. Question is there any mechanism? We're doing mechanism design, so we're asking not any specific mechanisms, can there be any mechanism that do that? Okay? Bitcoin has solved that problem in some sense, right? So you do proof of work is a mechanism. Problem with that one is if you have private value, and in Ethereum, certainly there's private value of proposing blocks, right? We have even a secondary market for proposing blocks called MEV Boost. If there's a secondary market for proposal rights, it means people have different value. Otherwise, there wouldn't be a secondary market, okay? So, and that value might be private information to people, right? Because there's things like payments for order flow, or there's private order flow that people use to produce blocks. Or they do searching the builders and so on, right? So there are ample reasons for private information, private value. Mechanism design, in the end, has one insight. If you want to learn anything about mechanism design, that's that thing. It all depends on private information. We want to elicit private information from participants in the mechanism, right? And so we turned Ethereum roadmap discussion into a mechanism design problem, okay? And then we can ask questions about it in a formal way. Can there be any incentive-compatible mechanism that selects proposer? Classic work from the 80s, we know exactly what are incentive-compatible mechanisms for the setup, so-called monotonic mechanisms. Meissen has told us about them. Here are some examples. We run an auction, we run a lottery, we run the lottery proportional to your value, and so on, etc. PP. It's a huge space of possible mechanisms that you can do. But here's a twist. If we add this requirement of permissionlessness, of the Sybil-proofness, then basically only one mechanism survives, right? And that's a punchline of the paper. There's only one mechanism, it's an auction. So we have to allocate through an auction. And it's super centralizing, right? That's what we know about auctions. So, in other words, can we have a decentralized builder market? Basically, any market structure with significant private value will lead to builder centralization, right? So think about the gazillion proposals that are around there of restructuring the builder market or restructuring PBS or doing a tester proposer separation. Theorem in principle applies to that. If there's significant private value, probably we run in a pretty centralized market, okay? Let me add some reflections on this private value assumption, and then let's open it for discussion or questions. So why is a private value in block proposal, and how does it link to market structure? So that is a question you might ask. So private value comes sort of from private order flow, and as I said, searcher builder integration in Ethereum. So how would we how would we remove it from the market structure if we cannot have a decentralized market structure with private value? Maybe we want to allocate rights in advance, so that's one class of proposals. So this execution tickets or execution auctions or even POS, you can think of such a system. Or we could put constraints on the proposer. So things like inclusion lists or like multiple concurrent proposers, they're trying to go that route. Okay. First proposal, allocating rights in advance. I think there is sort of, many people have made this point that probably one downside of that is that we naturally have a secondary market, so we replicate the market structure in the secondary market, which is super centralized. That's basically the status quo. So I think there's no way around that. That's my opinionated take. And constraining the proposer, I think some of the proposals like inclusion lists I mean, they make sort of the bad effects of centralization less bad, but certainly they don't remove centralization. And then we can think of other proposals like MCP, where in principle also our theorem applies. So there we would also expect market concentration, unless maybe there's a very smart way of constraining the builder in these proposals. I'm running out of time. Opinionated conclusion. Centralization is a thing. We have to deal with it. And maybe one route out of it, that's the Flashbot's proposal, I guess, is modelizing, decentralizing the builder role, the builder stack, or we think very, very long and carefully about other designs. Okay. Paper, here. Scan it.
Yeah.
Sorry, it's gone.
No.
No! It's on archive.
Okay. Well, thank you very much. So we have time for a few questions. Raise your, okay, not far.
Thanks for the talk. Can you repeat the name of the paper?
It's called On Simple-Proof Mechanisms.
Thank you so much.
Thank you for shilling the paper.
Any other question? Please raise your hand if you have any question. Over there.
What do you think of block building inside a TE?
Did we hire you to shill these? No.
Only recently.
This wasn't planned. I'm very bullish on block building inside of a TE, obviously, because that's one way of. So here's the thing, right? So if you have this market structure that will naturally lead to builder centralization, then we want to maybe constrain the builder, the powers of the builder, and one way of doing it is using cryptographic tools or programmable privacy tools. And yeah, definitely, TE is one of those solutions.
Oh, one over there.
So if every mechanism eventually ends up with a centralized block builder, why, when we look at other chains like Solana, do we not see just one big block builder?
We see a few, right? Is the answer. So we see a few. So that's I mean, do you call Solana block building market decentralized?
I'm the one asking the questions here. So is the idea that is the
no, but I'm questioning sort of you say a theory is rejected. I'm saying, is it really rejected?
Well, I think no one would agree that Solana's blocks are being built by a single entity.
I also didn't make the claim. I just said we have a centralized market outcome.
And when does a market become centralized? When does it qualify as centralized?
Few builders building all of the blocks.
Thank you.
And the punchline of the paper is, you know, there's no clever mechanism that can solve that. You have to solve it through other ways.
Okay, well, thank you very much. Give a nice round of applause to Christophe. So our next speaker is going to be Dr. Agaki Mamageshvili. He's a PhD in computer science and a postdoc senior researcher in microeconomics. He's currently working on economic issue of blockchains rollups, and he's going to talk about latency advantage in sex-dex arbitrage. Please welcome Dr. Mamageshvili.
So hello everyone, welcome to the presentation. Today I will talk about MEV capture through time advantage arbitrage. So this is the title of the paper that we wrote together with Ed Felten, Robin Frisch, Maria Silva, and Benjamin Lifshitz. And this is different from the title of the session. So take your time to take a picture or write it down. It will be gone, I cannot go really back. So initially I submitted as a 20-minute presentation, but it was demoted to 5 minutes. So the only thing I can do is to motivate you to read the paper. And I hope I can do that. Okay, so main part, motivation. So we try to understand what time boost does to MEV. And to give you a very quick introduction in the time boost, this is selling fast lane license that allows one player to have 200 millisecond advantage over all other players. And this advantage lasts only for 1 minute. And after 1 minute, there will be another auction. Then advantages, of course, achieved by delaying all the other transactions by other users. And we want to understand the arbitrage between automated market makers and outside markets. So we have a lot of assumptions in order to derive our few theoretical results and many simulation results. So we assume that in the outside markets, fees are very low, or let's say 0, and the price discovery happens on the external market. On the IMM that is on the chain, it's only arbitrage transactions. Of course, there are some noise transactions as well, but we assume that they can go into both directions, so they cancel the effects. We also assume the efficient market assumption, which is that the price depends only on the current, so price change doesn't depend on the previous price changes. So it's a pure random process, which is, of course, not true in reality. And we even observed on the data that it's not true. So the model looks like this. We have this one player that has this time advantage during time t. There are two assets, one risky asset and the numeraire. Think of as Ether, risky asset, and numeraire USD, or the other way around. The AMM has a trading fee, and the risky assets price changes on the outside market. So initially, we assume, initially of the simulation, we assume that they are the same, the prices are the same. And then once the arbitrage opportunity arises on the outside market, so price moves, then arbitrager needs to decide when to capitalize on it. And we assume that it has only time, advantage time. So after this time passes, opportunity will be taken away by other arbitrageurs. And this is a conservative assumption for the arbitrage value. So this reduces to an optimization problem. So we have time advantage arbitrageur, and we have 3 parameters that give a state. What is the current price difference, relative time, so price difference? How much time passed in this 200 millisecond? And how much time passed in the total period time? And we need to decide between trading, so taking the arbitrage, or waiting. And the punchline here is that dynamic programming solves this problem. And then dynamic programming, we simulated on the real data. So we took, let's say, Ethereum USDT market on the Binance, and with step size 10 millisecond, we have advantage window 200 millisecond, and total time 1 minute. And we can calculate for each point, internal point, we can calculate what is the optimal move, and also what is the average gains, average arbitrage value. And we obtained the observation that waiting till the end of this advantage time is mostly optimal, but not always. So there are some cases when it's not optimal. So I will not give you any numbers because that's the only thing that people remember in the end, how much money time boost makes with these assumptions. But it gives some upper bound on this type of arbitrage, so centralized exchange, decentralized exchange arbitrage. Additionally to this, we also looked into opportunity to let the pool contract know about time boosted transactions, which allows them to price such transactions differently, and this introduces some interesting game between LPs and the time advantaged arbitrager, and then we can calculate what will be the distribution of value between these two and other arbitrageurs. So thank you for your attention. Happy to answer questions about this and the time boost in general.
Thank you very much. So raise your hand if you have any question. Yep, over there, there first. Oops, sorry. Sorry.
Do you think it's a good idea to use 1 minute allocations to arbitrageurs? Is it too long? Have you tried to do shorter simulation times? I ask for, because MEV, multi-block MEV has been a problem. We don't study very well. So have you tried to simulate shorter?
So in simulation, of course, you can simulate and get results, what you get. But we thought that 1 minute is not very long because if you make it, if you make it longer, it's even worse from your perspective. But if you make it short, then we need to conduct this auction too frequently. And that also has some cost. So that was this kind of trade-off that we analyzed.
There's another question over there.
Did you try this using real money? And did you find anything interesting between real and simulation?
So we didn't try real money, but you are welcome to try. We analyzed the backtesting, so this was data was taken in July. But in principle, you can forward test that too, once it's there. But you can also forward without time boost deployed on Arbitrum. You can just assume that you have this advantage, and you can then see how much you can make with the strategies that we suggest. Yep. So answer is it's very easy to do, but we didn't do it.
Hi, this is Kenneth, and I'm not sure if you covered it, but was any differential gas price that was taken into consideration in your simulation?
So what differential I didn't get?
Gas, like the amount of gas fees that you for decentralized exchange.
Decentralization.
Yeah, the gas fees.
So gas fees we assume to be, let's say, sub-cent for the exchange. So we took realistic gas fees and subtracted from the gains. But they are very not substantial for the results.
I see, thank you.
There's one last question over there.
Oh, over there? Okay.
Over there, yeah. Sorry.
Yeah. What kind of inventory is needed to actually pull this off in a relatively profitable manner?
I mean, you need to have both assets on the chain and on the external exchange to try this strategy.
Yeah, but I guess I'm just looking from from a volume perspective of what they actually need. Like in your simulations, was there a drop-off point where, let's say, if they only had 100K versus 500K, it's no longer profitable?
Yeah, actually, sometimes you need very large inventory to realize very large price difference. But we didn't go into this. We assume that you always have enough. But you are right that to take this advantage, you can check numbers. To take very large advantage, you need very large inventory as well.
So that was the last question. Thank you very much for your talk. Please give a nice round of applause to Akaki. The next speaker is going to be Dr. Theo Diamandis. He holds a PhD in mathematical optimization at MIT. He's a research partner at Bain Capital Crypto, where he works on problems in crypto economics and DeFi. And today's talk is going to be AMMs as managed customized portfolio. Please welcome Dr. Diamandis.
Thank you for the introduction. Hi everyone, my name is Theo. I do research at Bain Capital Crypto, and I'm also going to talk about decentralized exchanges. I want to kind of focus this conversation around the liquidity providers, and this talk is really going to be a call to action for some research and then also product development that I think would be quite interesting. So let's look at the value of an LP position in an AMM. I'm going to say that we have two assets. One is a numeraire, and the other is some asset, whatever you want. with price P valued in terms of the numeraire. So you can think of maybe the first asset is Ethereum, the second asset is some other token, and P is the price of that other token in terms of Ethereum. And this AMM has a set of allowable states. So we can think about it as having some set of reserves, and it says, I will let the reserves change in particular ways. So what's the value of the liquidity provider position? Well, if we assume there's one arbitrageur, at least one arbitrageur, who's going to try to extract as much value as possible from the AMM, we get this minimization function, this minimization problem, which essentially says the value of an LP position is the minimum value among all the sets of allowable reserves. So for what's most common, which is the constant function market makers, that set of allowable reserves is just going to be essentially some invariant evaluated at the reserves that has to be greater than or equal to some constant. So just to make this very concrete with an example, let's take a constant product AMM, so things like Uniswap v2. And for that, we're going to have this square root invariant. If we plug this in and kind of go through everything, we get the value of the liquidity provider position at time t, so at t amount of time after this position was opened, is essentially proportional to the square root of the price plus a term that depends on the fees. So we look at this, and there's a few questions that one might ask, or a few kind of considerations. First is, do I want this derivative? Do I want this product? Second is, what rebalancing cost am I going to pay arbitrageurs to maintain this position's value for me? And then third is, can I hedge the price movement? Let's say I just want fees. I just want fees for providing my liquidity. I don't want to be exposed to the price movement. How easy is it to hedge this? So I'll review some of the current research, which is mostly on this first question, do I want this derivative? And there the question is, okay, well, let's say there's something I want, so some portfolio value V that I want. How do I get to an invariant for a constant function market maker that gives me said value? We see some examples in practice. I'm using this loosely, but things like zero coupon bonds at maturity, some of the yield token pools look kind of like this. We also see things like weighted portfolios, so things like balancer pools, geometric mean market makers, some of the perpetual exchange lending pools look kind of like these weighted portfolios. We've seen covered calls on chain and other people build options on top of AMMs. And then we've also seen recent proposals for things like prediction market AMMs. There's a recent blog post from Dan and CMAC on that. The general theory for the static case, so for the case where the time t doesn't matter, from replicating market makers papers in 2021, 2023, says that if that portfolio value function is some concave homogeneous increasing function, we could figure out the CFMM that gives us said function. However, this doesn't really tell us why some of this stuff works in practice, some of this stuff doesn't seem to have worked in practice. How do we do it in the dynamic case? That was only in the static case. And there's a few things that I think at least are key factors here. For that, I think the ease of hedging the price movement. Essentially, if LPs desire some delta neutral strategy, so they're not taking risk on the price of the underlying asset, how do they do that with an AMM? So they just essentially want the exposure to the trading fees. Second is the amount extracted by arbitrage. So if you've heard lever thrown around, or we can think of these as rebalancing fees that you have to pay to arbitrageurs, how much is that? And like essentially how much leakage is there from my portfolio value? Third is just how useful is it to have one of these custom portfolio value functions? Like what are essentially derivatives that I might want to have? Is the portfolio value actually useful or not? So the reason that I think that looking at this is exciting is there's over $10 trillion of assets in ETFs. There's a lot of passive liquidity out there. Clearly people are doing stuff in kind of the financial world with this. And I think there's a lot of opportunity to bring this liquidity on chain. So if you're interested in collaborating on these types of questions on the research side or on the practical side, please reach out. Thank you.
Thank you. So are there any questions? No questions? Raise your hand so I can send you the mic. Okay. Okay, all clear. There's a question here.
You didn't talk, you didn't expand in detail, but can you, is there a brief introduction about what are typical ways of hedging the directional move?
It depends on the, actually I think this is kind of a issue in a lot of AMMs because for instance, if you wanted to hedge like say a constant product position, you have that square root function that's your long exposure to the asset, and most places to get short exposure are giving you a linear short exposure. And so what that means is the amount that you need to be short that asset is going to change as the price changes. And that makes it very difficult because you have to constantly be managing this, the short position, the hedge of the short position, which means that it's like no longer passively providing liquidity. And there's a number of blog posts, if you message me, I can send you from kind of a few years ago that talk about this. But in terms of the question of like, how do I design a portfolio value that is easy to hedge, I think this is a pretty interesting area of research moving forward, especially the dynamic case where the CFMM or the automated market maker might be changing over time.
There's another question over there in the center.
How do you think about concentrated liquidity provision, in particularly regard to hedging as you described? So if I'm an LP and I want to, only provide liquidity within certain bands, how do you think about that in regard to the rest of the formula?
Those also actually do fit in kind of the standard constant function market maker framework, even the constant liquidity pools. There's a paper that I wrote with a number of colleagues called The Geometry of Constant Function Market Makers that shows that connection. Essentially, the high-level idea is one way to think about all of these things is there's like some set of reserves that's allowable, kind of that first slide that I had, and that set has particular properties for, let's say, like the things that you want to hold. So even, say, a concentrated liquidity position, whether that's like the Uniswap v3 hyperbolic type concentrated liquidity, or if it's linear concentrated liquidity, you can even in some ways think of an order book as linear concentrated liquidity positions, because for whatever you're selling, it's just kind of a linear amount. So this all falls into a similar framework. And actually, I think that's one of the things where kind of the more we can bring this all into a common framework, we can start to use more interesting mathematics and then really push forward our ability to like understand this stuff and build end products. Happy to talk more offline. Thank you for the question.
Okay, there's time for one final question. Over here.
What do you think is like the right way of thinking about these portfolios for users? Because crypto is quite a unique place where you need to put like these two tokens in these AMMs. And traditional market makers are looking for optimizing USD. Do you think we are looking at maybe the wrong metrics when we are measuring these kind of performances? Should we build portfolios for these two kind of tokens? What's your take on that?
So sorry, if I understand the question correctly, it's like what types of portfolios should we be?
What kind of products are we trying to design?
I think that's a good question. I think right now there's the first kind of step to answering that question is to figure out, what might we care about, and then how do we design for those types of, for those metrics. I think there's a question of like what the metric should even be, and then after that we can kind of, look into how to actually construct those portfolios. But I think the exciting part is the design space is pretty wide open right now. And of course, we can look to finance has a long history that we can look for inspiration to.
Thank you.
Well, thank you very much. Please have a nice round of applause for you. So our next speaker is going to be Nipun. He's a co-founder and core contributor of Infinite. He previously co-founded Alpha Finance. He was the first to introduce leveraged yield farming. And today's talk is going to be deep dive the LP pricing. Please welcome Nipun.
Okay. Hello, everyone. So my name is Nipun from Infinite, DeFi abstraction layer. So today I'm going to give a talk about LP pricing. So before we start, what is LP? Everyone might be familiar. It's like a share of the pool, depending on where you lend, where you deposit, Uniswap, Curve, Aave, Balancer, any kind of pool. And you get an LP token in return. It may be ERC20, maybe not. LP pricing, why is it important, right? It enables more use cases. It creates more composability and capital efficiency, where you can reuse the end product, the shares, to be able to create more leverage, lending, borrowing, more use cases, right? LP value, right? It's easy. It's whatever is in the pool divided by the shares, right? But you know, this is not true, not so easy. Life's not so easy, right? Many hacks in the past has occurred because we're using spot price and sandwich attack. You can manipulate the price, or you can even inflate price per share for the LP, right? So this talk is going to be focusing on the high level of what's important to compute robust LP pricing. So LP price depends on two major things, right? One is, what are you going to use the LP for? Use cases, are you using it for collateral or using it for borrowing? Second part is, what LP types are you using, right? It depends. Are you using UniV2 LP token, which is ERC20, UniV3, which is ERC721, or V4, or even Curve, or other AMM invariants, right? It depends. So moving on to use cases. So this will determine like what kind of pricing is needed for your use case. So for example, if you're going to use LP as collateral, then you don't want to overestimate your price, your LP price. Why? Because if you're using it as collateral, then you don't want people to be borrowing against your collateral more than the value that you should have, right? So if you use collateral, don't overestimate the price. Second part is, you don't want the price to dump, right? You don't want to have your collateral suddenly dump price by 50% just because your algorithm is prone to manipulation, right? So it can lead to bad debt because the borrow value stays the same. LP collateral value suddenly drops, right? You can, however, underestimate the price at the cost of efficiency and at the cost of liquidation risk for users. On the other hand, if you're going to use LP as for borrowing, then it's going to be the counter argument, right? You don't want to underestimate the price, because otherwise you can borrow out more value than what you should have. At the same time, you don't want price to pump for the borrowing tokens, because suddenly your debt suddenly can skyrocket and then cause bad debt in the system. And that can lead to attack vectors. And at the same time, you can overestimate the price of the borrowing tokens, but at the cost of capital efficiency and also liquidation risk for the users again. So this is for LP use cases. LP types, there are many kinds of LP types, but it'll define what kind of pricing can be implemented. For example, in UniV2, you can donate money, right? You can transfer tokens and then you call sync function. So that means price can pump at the cost of money for the attackers. So you should not enable borrowing for UniV2. In V3, you can increase liquidity. Again, anyone can increase liquidity, increase the value, price per share. So you don't want to use this as a borrowing, as a position as well. So this is some things that we need to keep in mind. An example of LP types, UniV2, UniV3, you can find exact formula, Balancer, generic Uniswap V2. You can also find exact formula using Taylor approximation. Curve stable swap, you can use gradient descent, solidly, Pendle, GMX, Trader Joe, whatever, and other forms. You can always find some form exact and maybe some approximation. So just a quick example, you derive fair balance and then you derive the fair pricing for the LP. And I'm not going to go through the exact formula, but this is the rough calculation of UniV2. In V3, it's going to be slightly more complex. So you derive from the price, and then from price reaction, you derive back to the fair pricing for the LP. So yeah, thank you.
Thank you very much. Thank you. So do we have any questions? Please raise your hand. Over there? No. Over there.
What's the best place on chain to use Uniswap NFTs as collateral?
The question is, what's the best place to use Uniswap on Uniswap in V3, right?
Yeah, I suppose so.
I am not sure right now, but there are many protocols that are building on top of UDV3, allowing to lend and then you borrow out. Also, I think there are leverage U farming protocols for sure. And there are also, I think, I'm not sure if Aave is allowing UDV3 position as collateral or not. I remember they did back in Aave V2. They have like AMA markets, but they are not so much usage. Yeah. Thank you.
Okay. There's another question in the middle.
Okay, hello. Yeah, I just want to answer your question. The best protocol is Panoptic.
Any other question?
Back there.
Hey, I'm curious to know if there are no Oracle pricing for a token in an LP pool, how could you still get the fair value of the LP price?
If there's no Oracle price, right? So
Yes.
so this is given context of if you have Oracle price for the base asset, right? That's a good question. And the answer is going to be tricky because if there's no true price or the base for the base assets, then what do you treat it as what's actually a correct price, right? If the asset is only available in a DEX, for example, if you use like Pendle PT token, usually the pricing is derived from PTSY pool itself. And I think you could find other source of PT pricing. For example, you can use TWAP at the cost of time and risk. But yeah, so there's trade-off because if that's the only place where you can derive the true price, then that is a true price, right? So in LP pricing, what you actually want is a robust pricing where you don't want to have like a manipulatable price by flash loan, flash swap, everything else. So there should be a reference where we should find what is the correct price.
Thank you. That was the last question.
Thank you.
Thank you very much. Give a round of applause to Nipun. So our next talk is going to, our next speakers, sorry, are going, there to be two of them actually. There's going to be Alan Wu, who is a protocol engineer at Uniswap Labs, and Dr. Brad Bashu, who is a researcher at Uniswap Labs. And the topic is going to be time is all you need, optimizing Dutch auctions on Arbitrum. Please welcome to Mr. Bashu and Mr. Wu.
Hi everyone, my name is Alan. I'm a protocol engineer at Uniswap Labs.
Hi, I'm Brad. I'm a research scientist at Uniswap Labs.
And today we'll be talking about optimizing Dutch auctions on Arbitrum. When we think about swapping on-chain, we typically think about trading against AMMs. But using AMMs and on-chain liquidity isn't always the best for every single trade. This is because of reasons like liquidity fragmentation and MEV. We want to be able to expand the realm of accessible on-chain liquidity while also opening the door for off-chain liquidity. A pattern that's used to achieve this is using intents, where a swapper signs an intent to swap token A to token B, and they don't care where the token B comes from. They just want it to come in a reasonable amount of time and get a good price for it. So thinking from this perspective, it's a simple problem that swappers want two things: good pricing and fast execution. Today, there are systems that get us good pricing and fast execution, like RFQ systems, but they often run into problems around complexity and fairness. They're also relatively difficult to analyze and execute. So today, we'll be talking about a simple approach, which is using Dutch auctions on-chain. A Dutch auction is an auction where the price starts high, and it gets lower and lower until the price is taken. This is called a price decay. So the price starts high, and it decays lower and lower until market competition fills the order. If you set the price too high, then the auction will take a while to fill. But if you set the starting price too low, then you'll just get a bad price. So we're left with a simple question: how do we set this Dutch auction optimally? And the answer is time. Time is all you need.
So as Alan mentioned, when you hold an auction, it takes some time for your auction to get filled. We can call this wait time. We can actually design a system that depends on mainly this output metric, wait time, to give the user the best price possible. So in other words, we can avoid the problems of complexity, fairness, and difficulty to evaluate without compromising on execution quality for the user. So to test this idea, we made a simulation. And this simulation depends on market prices, AMM prices, takes into account price impact to create reference prices, and then we run multiple Dutch auctions across this price background. On your bottom left corner, you'll see two output metrics, fill rate and wait time. And we tell this algorithm to aim for a wait time of 4 seconds. On the bottom right-hand side, you'll see the parameters of the Dutch auction tuning to try and achieve this wait time of 4 seconds. And in particular, in the bottom right chart, the x-axis is a parameter that can give you an approximate value of how much price improvement you're getting. And this value is meaningful when it converges to roughly, in this case, 4 seconds. So what I've shown you is that, and one thing is that the maximum price improvement that I injected in the simulation was 25 basis points. And as you can see, it converges to this 25 basis points. So I've shown you that I can only look at one simple metric and give the user best price possible with the ability to evaluate what that price improvement is. So let me give you some intuition behind what's going on here. So the red dots here represent the auction prices changing with different parameterizations. Your auction gets filled when the market price goes above the auction price. When a user comes in to swap, for example, at block 10, we can check the AMM price, generate a reference price, and use that to parameterize on our auction. So what happens if you parameterize your auction too low? If you start off too low, you get filled instantly. This is bad because it means you could have gotten a better price. What happens if you parameterize the start of your auction too high? You get filled much later. This isn't necessarily bad, but it makes your auction harder to evaluate. So if you get filled within the first or second block, or first couple blocks, then that period tells you that you parameterize your auction just right, and you still give the user the best price possible. So using this strategy, we can compare it to other strategies of parameterizing Dutch auctions. You can think about using sex prices. If you use sex prices, then you run into the problem of fairness. You guarantee fairness, but you can't parameterize every token. If you use RFQ, you kind of compromise on fairness, but you can parameterize every token. In all cases, you compromise on ability to evaluate. Our strategy satisfies all these criteria. So this is just the beginning. We're testing this out in Arbitrum, but this can work on any Dutch blockchain-based Dutch auction. And we think this is a step towards testing out nonlinear auctions in the future. Thank you.
Thank you, guys. So do we have any questions over here? Yep. Thank you. That's fine. A bit short.
Thanks. So what does time boost do to your design?
So in time boost, you pay extra to come in first, right?
Yes, but imagine, so ignore that factor, but there is one player who has this 200 millisecond advantage.
I think the user gets better price. I don't.
That user.
That user, yeah.
Thanks.
No, what's important is the filler. It's an open market on the Dutch auction, so it doesn't really matter. And yeah, I don't think I understand. It's an open, anyone can fill. So
yes, but one party has time advantage, like.
So you're saying if the filler has time advantage?
Yeah, let's say filler or the other.
Yeah, so if the filler has first move in that block, then in that particular block where the price decays to where the true market price is, where they would want to fill, then yes, they would be able to snatch that before other people.
We have one question right here.
Okay, so if I understood correctly, you're running this auction for each token simultaneously or just one at a time?
So whenever a user makes an intent to make a trade, that trade itself is a single auction that's going to run on chain for people to fill.
But if there are multiple auctions running parallelly, there is a lot of arbitrage opportunity because the prices may not agree.
Each auction for each trade is unique, right? They have their own unique parameters. They have outputs that the users are expecting, so they are distinct.
So let's say if there is an exchange between USDC and ETH going on that's priced at 300 and there's somewhere else, the opposite trade is happening at 1/400, like there is a arbitrage opportunity across these two places if somebody can submit 2 bids and profit.
Yeah, so if the person who's filling that auction, there would be an expectation if they're behaving rationally that they must have sourced the liquidity somewhere else in order to fulfill that trade on chain.
I think I put in an assumption in the simulation that you're probably saying it's not necessarily the market price that determines the fill. And what determines the fill is if whoever is willing to give the best price, and that's all we care about. The best price we can capture for the user, whoever decides to fill it. So not necessarily at the market price.
We have one last question over here.
Hi. How do you account for the liquidity when you're doing the testing? Since if you only test with like a small amount in your trade and it gets filled quickly, but then when you adjust it and you want to swap more, then you're going to get hit by liquidity.
You're going to get hit. You mean
you're going to like the
price
will
impact?
change. Yeah, the price.
Yeah. So I think what I showed you is a simple version where the price impact is you take orders of roughly the same size and you run this algorithm. You can either choose to bucket by trade size and run this algorithm or have a smarter algorithm. I didn't really talk too much about how the algorithm was working, just the intuition behind it.
Okay, well, thank you very much. Thank you, Alan and Brad. Please give them a nice round of applause. And now we're going to have the last talk for the crypto economics track today. So we're welcoming back Terence for his second talk of the day. And he's going to talk about inclusion list inevitable trade-offs. Please welcome back Terence.
Hello. Hi, I'm back. Thank you. And yeah, so this one is more, again, on inclusion list, and it's more on the engineering side that as someone that has been focusing on inclusion list over the last year, and I also started looking at fossil more and more, and this is where my perspective in terms of engineering challenge with regards to inclusion list. So today, where we are, right? So today we have Ethereum slot, and each slot is 12 seconds. And what are the constraints within the slot? So as a proposer, I want to propose a block. And I will hate to have my block gets reorg, and that's not nice. So I want to propose my block on the strongest head that's possible, right? And after I propose a block, everyone else on the network that's running a node will verify the block and compute what is the head. And as a tester, their job is to attest to the head of the block. So this is where the for choice follows if you use LMD Ghost. And then as an aggregator, as optional, you aggregate attestations. And then the proposer essentially follows the votes for the next slot, and then it builds on top of the head, right? And then because of timing game, you can see there is a phenomenon that today, the attested cutoff is at 4 seconds. So basically everything is pushed towards the 4-second mark. And that's kind of the equilibrium right now, that everything happens between 3 to 4 seconds. And then between 4 to 12 seconds of nothing typically happens unless you are the next slot proposer, you're listening transactions, and you're building block. So where does inclusion this fit into this picture? So here I'm speaking in terms of Fossil. So Fossil is a EIP 7805, I believe, but go search it if you don't know what Fossil is. So Fossil is probably the best inclusion list design that I have seen so far that is mostly bulletproof in my opinion. And then it has the same slot property. And then, so what Fossil does essentially is that it essentially allows secondary runs of proposals that are allowed to send their local block, and then such that it can train the next slot proposer essentially. So where does that leave us in the picture, right? So because of that, we have to essentially add this proposer in the middle of the 12 slots. That means that as a proposer for the inclusion list, I have to essentially verify the block beforehand such that I want to essentially propose the best inclusion list effort, right? And then as a constraint, the next slot builder or the proposer, I have to essentially pack the inclusion list into the block. And then if I miss inclusion list, then I may miss my block. And also as a tester, I want to make sure that the block satisfies the inclusion list. So there are 3 more constraints as a builder, as a proposer, as a tester, which I cover here. So where are some parameters that we can play in terms of trade-off? So for example, how big is the size of how big is the size of an inclusion list, right? If the inclusion list size is so small that it may not be useful, but the inclusion list size is too big, then you open up network for DOS concern. What is the size of the inclusion list committee? Because we want committee size to be reasonable, but then if the size is too big, again, you open up network DOS concern. And then how much overlapping are there within the inclusion list? And then what is the satisfactory rule, right? So as a proposer for the next slot, as a tester, I'm verifying the block. Basically how much of the inclusion list the proposer has to satisfy for the block to be valid. So what are the concerns? So first concern, I think, is the increase of bandwidth and compute for node. Depends on how big your inclusion list size is. And then again, the second concern is that proposer, how much time do I have to build the block? And then as a tester, how much time do I have to verify the block? So here are some open questions for us to study if we're interested in this inclusion list space. How compatible it is with the future roadmap, such as Pierre does, such as EPBS. How does inclusion list work with account abstraction? And then how can we add blob transactions into the inclusion list such that it doesn't open up DOS concerns? And then how can we better utilize local mempool for inclusion list? Maybe we can just essentially send the transaction hash instead of sending the full transactions. Finally, will there be an auto protocol market for inclusion list? And it's something that we need to study more. So yeah, if you're interested to contribute, definitely hit up Julian and then hit up me. And then yeah, definitely, I'm definitely very excited about this inclusion, this design space. Thank you.
Thank you. So now we have time for a few Q&A. Please raise your hand if you have any question. Okay. questions? Okay, seems, oh, there's a question here.
Yeah, super interesting. I had a question. So I don't know if you can answer this, but in any capacity, are you thinking about doing fossil or inclusionless for L2s like Arbitrum? Or yeah, and how does that differ from what's in the EIP and what could be on mainnet?
Right. So layer 2 today is most of the layer 2 or all of the layer 2 today, they have just one sequencer, right? So the sequencer definitely have a lot of power. Say today, if you want to force your transactions in there, like if sequencer ignores you, there's nothing you can do. But then there's a lot of people say, well, you can force transaction through layer 1, but that's also not nice because you have to wait like 24 hours, right? But then like, again, I think like decentralized sequencer kind of solves that if you assume an honest majority. So I would say the space in terms of censorship resistance on layer 2 is definitely very different on layer 1. Because on layer 2, you can essentially having like 1 million validators, you could just have like 10 sequencers and then trust like honest majority. And then as long as you assume some of them are honest and they like basically they have to include your transactions.
Any other question? Okay, well, thank you very much for your talk. Please give some applause to Terence. And that concludes the track crypto economics. We're going to have a break, and we're going to be back at 10 past 5 to discuss Cipherpunk and privacy. back for the last track of the day. So we're going to have the different topics to discuss Cipherpunk and privacy. So the first speaker of the day will be Frank. He's currently leading the Waku project. He joined the blockchain ecosystem for the Cipherpunk values. And the topic of the day is going to be bringing peer-to-peer networks to all the peers. Please welcome Frank.
All right, thank you very much. Hi, everyone. Let's get started. So, bringing peer-to-peer networks to all the peers. What are we talking about? So, we are trying to create a peer-to-peer model for end-user devices to be included in this model. And by end-user devices, I mean desktop app, mobile app, web app in the browser. And here, more specifically, we are talking about libp2p GossipSub-based networks. So for those who don't know, GossipSub is what is used on the Ethereum network for the Beacon chain as a network layer. So the current status quo across most peer-to-peer networks is that we use REST APIs, Web3 APIs, and other web gateways to allow users in the browser, mobile and desktop to access a peer-to-peer network. Usually, anyone could run such API if they have the resources, but when building applications, whether web apps or mobile apps, usually the users or the developer will select one API or maybe a couple. So this does create some problems, and we are aware of that, in the Ethereum ecosystem, and initiatives like Client try to solve this problem around trust, data access, and propagation, privacy, and censorship of this API. I'll go in more detail at the end for that. So the first problem we had when started to use GossipSub on, again, laptop, potential mobile, and browser, is that it has very unstable connections. So if you want to compare that to Ethereum node, for example, when you're staking, usually you run your node on maybe a Raspberry Pi or DApp node or some on VPS, where connection is quite stable. But on a laptop, you are going to change Wi-Fi, you're going to go offline, back online. And GossipSub doesn't have any mechanism to help you with this specific scenario. So there's no acknowledgement. To know whether you're online is a bit hard. You can have some timeout from TCP. And you can miss messages when you're offline, right? Because once message goes through the network, it's gone. So the solution we developed uses GossipSub and DeFi for desktop, as well as a smart contract and zero-knowledge-based rate limit to ensure that you don't have too much bandwidth, too much traffic going on the network, so you can support this network on a household bandwidth. And we have a number of libp2p request-response protocol to enable browser and mobile to query for more peers, because DeFi can consume a bit too much bandwidth and resources. And I was able to push messages and get messages from the GossipSub network. So you still have a lightweight to get messages, but it's much more decentralized than the REST API. Finally, in terms of sharding, if you start to put 10,000 or hundreds of thousands of users on a GossipSub network, unlikely to work. So we do separate, I would say, the global network into smaller GossipSub network via sharding. So if you have a quick look at how it could work, so we have service nodes, VPS, that run in the cloud. They allow a mobile phone to go and query for messages they missed. Mobile phone could subscribe to a desktop node and say, hey, can you please forward messages that I'm interested in? Desktop node goes offline and then back online, can also query messages to a service node in the cloud. And finally, a browser can push messages to a service node via WebSocket that we then get pushed on the GossipSub layer, which we call a relay in our case. All right, so we did have to add redundancy, right? GossipSub has some built-in redundancy. We had to add that when, for example, pushing messages, we push to a couple of nodes. And we also had to add end-to-end reliability protocol so that in the context of a chat application, you know whether, or you have some idea whether your recipients, other participants in the group, have seen your message. And the result is that now you have some redundancy, and you can check message presence using various nodes to access the network instead of trusting one single REST API. You do have some improved privacy because instead of having all your traffic going through one REST API, you can select various peers and decide what traffic you ask from them or you push to them. And in terms of censorship as well, it means that you do not rely on a single DNS, a single domain name, for example, and a single REST API, which could be censored or blocked. But instead, you apply a peer discovery strategy, allowing you to access the network via different peers. That's it for me. 5-minute presentation. I think time for questions.
Thank you very much. So we're going to have a bit of time to ask some questions. So are there any questions? Please raise your hand.
I think you mentioned status as one of the users. Are there any other apps using this stack or approach you highlighted?
Yeah, of course. So yes, so the status chat app uses that, and they have a mobile app and laptop and desktop app. We have Railgun. Railgun is a private DeFi systems where they have a zero-knowledge smart contract, and you can do DeFi without revealing your Ethereum address. And they do use Waku on their mobile, web, and desktop app, where the wallet has Waku running inside with the LP2P. And I can send messages, can send basically the transaction, the proof that they have a node to broadcasters which are not in the cloud, which then takes the transaction from the wallet and push it on chain.
Okay, thanks.
And we also have other projects. I mean, Railgun and Status are the most advanced ones, the most mature ones.
Yep. I think there's another question in the middle. No? Okay, no. Go ahead.
Hi. So my question was, first is why REST, and second is why not gRPC or RPC?
Why are we not using gRPC?
Yeah, gRPC or RPC.
So in the case of, so in terms of lower protocol stack, right? We're using TCP and WebSocket. I'm guessing you're talking just above. We're not using gRPC instead of LP2P, I guess. Yes. So LP2P does come with a number of useful tools. So when we start to build and starting to use Gossip Sub, for example, it means that we are introducing one technology stack into the system, right? So we use LP2P Gossip Sub. And when we want to look at request response protocol, we could indeed start to use gRPC or REST API, but this means introducing new technology stack into the system, which means that having a heterogeneous technology stack means you may have more problem, and so it's just easier to continue using LP2P and define this request response protocol on top of LP2P. And LP2P comes with good things such as the noise handshakes, right? So you have a point-to-point encryption with LP2P out of the box. So you can just use that out of the box. Good question.
So we have time for one last question over here.
Could you share a few more words about the sharding idea? Is it, if I have an application that grows massively, would it start sharding itself automatically, or would that work?
Awesome question. So the idea with sharding first is that, if let's say you have 1 billion users, right? All the messages they generate will be too big to go through one household bandwidth, right? So the idea is to split the network so that you only look at messages you are interested in. That's the routing layer. We have a content topic, which is metadata, like just a string that you can attach to messages, which allow you to further filter messages you are looking at. So on mobile, you are going to only look at specific content topic, which will be a subset of messages on a shard. So now you have several options. You can either come in and your application use one content topic and you're going to just be part of one shard. And if you grow up, then you may want to look at seeing if you can use more shards. Or you can start in and have actually a big application from the get-go and just try to split all the traffic from the get-go. In terms of you can start with 1 shard, 2 shards, or 3 shards. Instead of growing to more shards, it's just a consensus between operators. So you can say, okay, we need 2 more shards on our network, and you can just tell your node operators, can we please support shards 10 and 11 now? And they can start to support it, and you can start to diverge traffic for it. So it's a bit of a manual process, and we haven't gone through this course pen yet, but it's many operator consensus here.
Thank you very much. That was the last question, so
Awesome,
you give some applause to Frank. So our next speaker is going to be Sebastian Burgel. He works at Gnosis as VP of Technology. He's a founder of Hopper and previously founded 2 other tech startups. He's an expert at building technical solutions that empower the individual. And so the topic of the talk is going to be Cipherpunk is slow, not hyper-financialized, and unlike Twitter. Please welcome Dr. Burgel.
Yeah, welcome and thanks for the kind introduction. My name is Sebastian. I got introduced already. So yeah, but today actually I don't want to talk about any individual projects because I'm talking about a problem that I think is bigger than any individual project that we're seeing here. And before I get there, I want to dive in how we come here. So a long, long time ago, in days so old that Ethereum had a vision. The vision was stated on the launch day website of ethereum.org on July 30, 2015. And that read, what is Ethereum? Ethereum is a decentralized platform that runs smart contracts, applications that run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. Ethereum is how the internet was supposed to work. On the page, you found how to, for the very first time in human history, actually do, fair voting. If you dig deeper, you found out how to launch your shitcoin without running a network. That was neat. Somebody came up with a horrible standard and called it ERC20, and yet people were building like really cool interfaces on top of it. The birth of DeFi. Well, the birth of DeFi and this DEX had a bit of problem that, if you look in the order book, only one person can basically buy the top of book, right? You wouldn't know who in the block actually got that. That's not great. Luckily, a young man came up with an idea, and another even younger man wrote a blog about it. And his blog can be summarized in exactly 5 characters. X times Y equals K. I think the most iconic equation of our times. And DEXs were born, right? And along came a third young man who at the time didn't even have a job or knew how to code, and coded up that idea and called it Uniswap. Now, if you use Uniswap, you might have seen the settings thing, you might have not seen it. There's something called slippage that fixes the issue I talked about earlier of not, taking this exact order only. Fast forward to last night, there was some fella who was again trading a shit token because that's what people do, 15K worth of shit coins for like 13.5K worth of ETH. Weird, what's that difference? Slippage? Of course not, right? So that's a sandwich attack. That fellow got sandwiched by a sophisticated front run and back run here. How is that possible? Well, of course it's possible thanks to a highly sophisticated, user screwing infrastructure. That's also called MEV. It was built to democratize access and make things fairer for the user by leveling the playing field and bringing many players into the field. So let's zoom into that. Let's zoom into this builder section down here and let's see how that democratization is going. Well, today we see that there's exactly 2 remaining, right? So that's Titan and Beaver. Congrats on democratization going well. And I think that is broken, right? That is broken. That is not how Ethereum was supposed to work. So an updated version of what is Ethereum 2014. Ethereum 24 edition, Ethereum is a platform that runs smart financial casino contracts, applications that usually run exactly as paid without any possibility of downtime. And yes, it actually once said third-party interference. Funny, right? Ethereum is Bernie Madoff's wet dream. And that is broken. And that's what I'm here to talk about. And that's what I'm standing up for, because that is not the Ethereum that I came here for. It is about them versus us. They want faster blocks, obviously, right? You can trade faster, you can make more money quicker. We want resilience via privacy and decentralization. And it is unfortunately at odds. Why is that at odds? Well, because physics. Because it takes a few hundred milliseconds to have a round trip of ping across our, not so tiny planet. And if you want privacy infrastructure, like mixnets that we build at Hopper or DVT that other people build, you have a bunch more of those, right? So things are not as fast, and that's why that's an actual problem. Now, they invest in restaking, RWAs, and rehypothecation. We empower the individual on the world computer. These two things have to share the same ledger and have the same infrastructure to share. They write checks, cypherpunks write code. They are here for the profits. We are here for positive human interactions and experience in the infinite garden. If you are here for profits, you are part of the problem. You are contributing to a system that is corrupting the underpinnings of the world computer that cypherpunks want to build really great stuff on. Let's fix that. Let's be conscious about that, and let's try to build an Ethereum that goes back to the roots of where it started in order to bring us the infrastructure that empowers the individual and not the trader. Thank you so much.
Thank you. So now is your opportunity to ask some questions. Please raise your hand if you have any question.
About the censorship resistance, there are still node operators that make vanilla blocks. So how does that compare to what you said?
So yeah, I mean, there are still some node producers that produce blocks, but that's not enough. 80% of the blocks that are showed are subject to that, right? And that's not great, right? So increasingly, even individuals are subscribing to the big builders, and that corrupts the infrastructure. For example, it's not just the L1. With based rollups, that directly translates to corrupting the L2s, right? So we need neutrality of the L1.
Hi, thanks for the talk. So you showed the website back in 2015 and 16, and I think one of the big things that changed was the DAO hard fork, and that split the community to some extent, but also kind of filtered away some of the cypherpunk philosophy. So why don't people just, the cypherpunks, why don't they just use Ethereum Classic?
Sorry, why don't they just choose Ethereum Classic?
Great.
Well, I think we've seen the attackability of that, right? So cypherpunks still deserve security, and cypherpunks still deserve security that they don't get on a chain that could, any time of the day just get forked away under their feet. That's not great. So I think cypherpunks deserve ultimate resilience more so than the profit maxiteers, because they can still go to Binance. If you want to make money, Binance is great technology, right? Please do trade on Binance.
Well, actually, that was the last question. Thank you so much. Please give some applause to Sebastian. So the next speaker is going to be Evan McMullen. He is the CEO and co-founder of Private Idea. Evan also founded Disco.xyz and was a director with Berkshire Hathaway and Consensus. So the topic of her talk is going to be Cypherpunk for Centuries, Coordination and Secrecy Across the Ages. Please welcome Evan.
All right, what's good, Devcon? How are you feeling? Excellent. Thank you so much for being here today. My name is Evan McMullen, and I am CSO and co-founder of Private ID, along with a handful of other honors throughout the ecosystem and throughout my career. How many of you would consider yourselves to be cypherpunks? I'm seeing some hands here. This week, there are a lot of brand new members of our community. who haven't yet had the opportunity to identify with that term, cypherpunk. And I keep hearing things in the hallways like privacy doesn't matter. So I think we need a little refresher of the reason why we come to DevCon, the reason we build with blockchains, the reason this industry exists at all. The cypherpunk movement originated in the late 80s as a response to the growing threat of centralized powers invading individual privacy. However, the origin of this ethos and associated tech far precedes the era of networked computing. So let's look at the root of what got us here today. Around 2600 BC, the Mesopotamian kings had servants take a block of stone and carve their names into it, placing it in the middle of the town square in a show of force and declaration of power. Then, after that king, the next king had his name carved on a giant block, had his servants come down to the town square and put his block on top, showing the closure of one epoch and the opening of a new window of time under his reign. This stack, a physical chain of command, became the first calendar. And ancient Mesopotamia, a thriving ecosystem whose governance was anchored in a protocol that measures time based on blocks, perhaps the first literal blockchain. In the Zhou dynasty, people started producing these metal pieces shaped like spades, but too thin for practical use. Instead, they were monetary instruments, inscribed with characters indicating denominations that facilitated transactions, providing access to services, representing assets, but having no intrinsic physical use. In medieval Ghent, not far from Brussels, there's a belfry where the city documents are stored inside of this chest. But this chest has 3 padlocks, each with separate keys held by separate parties. The room that holds it is also locked by 3 separate padlocks requiring 3 separate people. 3 of 3 multisigs required to push updates to the protocol. During 1870s Singapore, there were secret societies, each with their own rituals, practices, and symbols. These groups of people self-organized into cooperatives to provide employment, wellness, and address one another's social needs. Secret society membership was only valid if they were marked with seals on the bottom. The leaders of the secret societies, the signers, had seals carved in wooden blocks that they would stamp in these documents. Secret society stamps, zero-knowledge attestations only valid with the right private key signature. Barcelona in Spain was and still is the heart of the Catalonian economy. In the 1500s, Barcelona's mints produced fiat tokens which contributed to their wealth and global force. The church saw this practice and forked the protocol to create their own tokens. The design of the tokens would change seasonally, so you'd get new season drops only if you were locked in on the right day. As members of the congregation participated in the liturgy, they could earn additional tokens. If they held for a long time, they would get more. There were withdrawal periods when they could swap for fiat, and even greater rewards for keeping those tokens. Sounds like an incredible proof of work token with season-based airdrops, a robust incentive and staking program, and withdrawal periods. Also in the 1500s, the term privado was used to refer to a highly trusted advisor of the Spanish monarch. The privado was often a close confidant of the king and held significant influence over royal decisions, sometimes wielding even more power than the kings themselves, or than other royal ministers themselves. The privado was not an official government position, but rather a personal one that usually involved advising matters of state, diplomacy, and even personal issues, making the privado one of the most powerful sources of security in the kingdom. Unlike the rest of our examples today, we actually don't see a huge difference in implementation when it comes to privado. Privado is still the most powerful source of security and discretion for decision-making based on highly sensitive and contextual data. Privado is the most powerful source of security and discretion, the trusted advisor to the sovereign, and certainly to the cypherpunks. My name is Evan McMullen. I encourage all of you this DevCon to hydrate, be excellent to each other, and be cypherpunks. Thank you so much for being here, and I'll see all of you on chain.
Thank you very much. Now we'll have the chance to have a Q&A session. Any question?
Did anyone in here learn something new today? Excellent. That was the goal. I really appreciate your guys' attention. I'm not going to quiz you on medieval memes and cryptography, but if you want to talk about that more, my DMs are always open.
Okay, thank you very much. Okay, we're going to have a short break for 5 minutes, and the next session is going to start at 5:40. not hesitate to move towards the front to better engage with the speaker during the Q&A session. So the next speaker is going to be Miros. He's been in the crypto web space for 5+ years. He's an expert in development, product organization, and passionate about SSI, privacy, social justice, and education. The topic of his talk is going to be our approach to self-sovereign digital identity does not work in real world. Please welcome Miros.
Hello, everyone, and thank you for being here. I know it's like I know the party's already started, so yeah, I'm looking at you, Carlos. Thanks again for being here. My name is Miros. Thank you for the nice introduction. I work in Privado ID, and I want to talk a bit about why I think that and I say our because I consider myself to be part of the movement, Cipherpunk approach to self-sovereign digital identity does not work. So we have been trying for years, right, to build tools that will protect people and to use all the cryptography and technology that we have, but how far have we actually got? We are offering full user control, privacy, decentralization, anonymity, and business that is actually building applications for people to use. And I'm not talking about us, right, in a Web3 bubble. I'm talking about people here on the street. These businesses, they want UX, they want integration, they want compliance. What are the key challenges? Well, these, right? First one is the usability. Talk about private keys, verifiable credentials concept, multi-chain, a lot of words that are ununderstandable for a lot of people, right? Ease of integration, if we are talking about people that need to use our technology, or let's say businesses to use our technology. Decentralization, most probably not gonna work or comes with a lot of hurdles, right? And we need to work with legacy systems if we want billions of people actually to benefit from all this. Compliance, sadly, but we know that the KYC, AML, and other stuff are required, right? Like it or not. So the Cipherpunk vision of total privacy and anonymity is an ideal, right? And I'm not saying to kill that, right? We need to keep the ideal there and work toward that, but we need to change some stuff. I call for an incremental approach. I'm just going to take one example here, right? An opportunity, but there are much more of these out there, being the European Digital Identity Incentive. So they recognize the problem, right? That the privacy of the regular people, of the common people, is in danger. And their solution is not ideal, right? They offer selective disclosure, data minimization, verifiable credentials. It's a good step forward, but it's not Cipherpunk, right? But I think we should join this. We should hop on the bandwagon because we can influence things. We can try to change some stuff. And actually, this is why I'm here, right? I would like that this debate happens here between all of us and all of you that are out there on the internet. So what we could win, right? We could promote privacy-first standards. We could encourage more adoption. We can actually have more private and decentralized alternatives. Jordi Bailina yesterday in his talk mentioned, and I agree with that, although it's not ideal, right? I would rather trust my private data with a government than with a corporation. Again, it's not ideal, but it is a step forward, right? And no, this does not mean that we stop fighting, right? I invite you all to think critically about building, advocating, or using, right, the solutions that are both streaming towards Cipherpunk, right, but are adaptable and can be used in real world, right? Let's please try to balance, right, idealism with practical constraints. So we can achieve more with what we have today, streaming towards the ideal world, right? There were a lot of talks, and I like the talk that was here, the previous from Evin and the other one, right? And yesterday there were a lot of also talks about Cipherpunk movement. It is important. All of you need to join if you are not part of that. But again, I advocate for an approach that is incremental, that we think not only about ourselves, but we think about the people that are out there on the street. That doesn't mean that we do not need Tor, that we do not need all the tools for journalists, for people that are doing really important things. That, yes, but also yes for the common people, right? The struggle continues. I'm Miros. Thank you all.
Thank you very much. Thank you. So we will have some time to ask a few questions. Oh, raise your hand if you have any question.
I can throw the red square at you.
Oh, you want to?
No, I mean, I'm challenging. Right?
Oh, okay. Any question? Oh, over there. Do you want to throw it?
No. I don't want to hurt the CSO of my company.
Miros, obviously there are a lot of examples that you've described of ways in which things are suboptimal.
Oh,
now,
yes.
ourselves aside, who else is doing it right? Like, are there government leaders? Are there enterprises? Are there, idealists or leaders who we should look to in our institutional structures as potential partners?
I think yes. I mean, whoever was on a bunch of all these talks that happened yet, and they are going to happen tomorrow and the day after, there are people, right, that are trying to do all this. And of course, I know our team best, and we are trying the best that we can. But I really like, for example, that having the initiative coming from the European Union. That's 650 million people that tomorrow can have privacy towards Amazon. Yes, where do I sign, right? But that's not the end game. So there are people, there are things that we can do, and that's it, right?
No, you're right, absolutely. That's a great call out. European
Thanks.
Union, and also shout out to the Ethereum Foundation for showing up this week on this topic too.
Yes.
Yep. Thank you.
And that's a drop mic, literally.
Any more questions? Okay. No? Well, thank you very much.
Thank you.
Please
Thank you
give
all.
a nice round of applause to Milos. And so our next speaker is going to be Ira. She runs her own design practice. She's an independent designer specializing in branding and visual design strategy. And the topic of her call is going to be visual code of cypherpunk and lessons from subcultural aesthetics we should remember on the road to mass adoption. Please welcome Ira.
Let's tune the vibe. So we all want mass adoption for our products, and we want these products to be loved and used by many. And yet we have one heavy anchor that will always hold us back from mass adoption: a visual language or cypherpunk. Let me show you what's happening. Visual language consists of two core layers. The symbols, they carry meaning and cultural baggage, and the styles. Styles evoke emotions. They always go together when it comes to how we respond to visual messaging. A positive style in a positive symbol in a positive style evokes joy. A positive symbol in a negative style makes rather negative impact. Think about toys in the horror movies. A negative symbol in a positive style can cause confusion, but rather it brings amusement. And think about Halloween. And a negative symbol in a negative style evokes nothing like fear and disgust. People try to distance themselves from everything that lives in this quarter. Well, adoption lives there. How do you think where cypherpunk is? Let's see. The first symbol, anonymity mask, traces back to Guy Fawkes, who earned a reputation of a failed terrorist and actually never fought for democracy. Well, Alan Moore tried to recover this image in the comics V for Vendetta, making it a symbol of vigilantism. But later, Hollywood successfully shifted the message, adding a narrative with a fear, creating taglines, and a lot of blood. Today, it's a symbol of cypherpunks. Now, here you already see a second symbol, hoods, that was originally associated with monks, the knowledge keepers, which is good beginning, but later that became a symbol of secret societies, many of which practice ritual murder and dark magic, if such a thing exists. And recently Hollywood dressed all the assassins in hoods, adding a nice layer of death and blood to the overall image. Today, hoods is a symbol of cypherpunks. Well, here you already see the next symbol, which is a common line romance, which, again by Hollywood, in a form of digital rain, together with the tech-noir style, presented technology as a global threat to everyday life. And the last style I would like to mention is glitch effect, which was a way for early internet artists to visualize a system vulnerability and the beauty of breaking it. But for normal people, the glitch effect evokes the same feeling as breaking glass. Now, how do you think where on this matrix cypherpunks are? Well, fortunately, we have a century of subcultural movements that can teach us how to ease this tension between our heritage and the past and the mass adoption needs. So here are three main lessons I want cypherpunks to hear. First, choose joy as a strategy. Cypherpunk looked like it was designed for post-apocalypse, but privacy should not look like paranoia. It should look like freedom. Just look how Pride movement turned the protest into a celebration. They didn't promote a better hiding spaces. They made visibility powerful and joyful itself. And you may say, meh, rainbows. But people love rainbows. Ethereum love rainbows. So we already want this joy. Next lesson, aim for simplicity. Cypherpunk visuals require technical tools to reproduce them. But if your grandma and even you cannot draw the symbol with anything that you have in your hands right now, it will not spread. Extinction Rebellion teaches us how to do. They created a symbol which a child could draw in seconds, and every human could reproduce with anything they have around. They later gave this symbol to communities, and communities style it with their own vibes to represent their emotions around the movement, and the movement went global. And last example, embrace evolution. Black Panthers used powerful yet very aggressive imagery, usually containing weapons. Because of this aggression, the movement didn't achieve the reach they hoped for, but the movement did not die. The new generation learned from the past and took over and moved from displaying weapons to displaying words, from we protect ourselves to we deserve to be here. And they reached millions and more. So if I were here, an incarnation of all the subcultural movements from the past, I would ask our ecosystem to not make Ethereum cypherpunk again, but to make it a new cypherpunk. And maybe, just maybe, it will also have a different name. Thank you.
Thank you very much. So we have a bit of time to ask a few questions. Raise your hand if you have any question. Over here. Oh, go. Yes.
Who's doing it right? Who can you call out, or are there any examples that you've seen this week of different ways to evoke this sentiment in our ecosystem visually?
You mean who is doing the right cypherpunk style, or who is doing the right in general? We are here right now.
So we have some more questions over there.
Hello. Thank you for the talk. So my question is, from the kind of negative examples that you presented, it seems like a lot of them were kind of, you know, serious, tough, masculinity focused. And crypto as an industry is also quite masculine in terms of just people who tend to, you know, run the companies. If we gather up everyone who works in crypto, mostly it's men. And one of the positive examples that you had was, you know, the pride flag, for example, which is something that is quite challenging to traditional masculinity. So how much do you think that plays into the current branding issues that crypto experiences? Thanks.
Well, I'm so glad you asked this, because like maybe 20 minutes before the talk, I just cut off one slide because I needed to fit in 5 minutes. But after the glitch effect, what I wanted to say is the Cipherpunk imagery has a very heavy gender coding and is all white male narrative, which is exactly what you tell about. All those movements that I showed, they actually show the equality of everyone. And what I really love in Ethereum here right now in Devcon is we have more of non-white people. So it's really good that white people are not dominating here. Also, if you study Cypherpunk movement itself, there were a lot of regional directions who actually didn't go for this American white narrative cypherpunk. And actually, for the original cypherpunk movement, Hollywood did a lot of bad job for us. Because as much as we were trying to narrate, well, developers don't do a lot of good job for the visual communication. So they did a lot of good stuff for like vision building. But Hollywood knows how to show masses what exactly the government wants to see. And in general, nothing goes on the screen which can harm the government. So even V for Vendetta, the author of V for Vendetta wasn't involved in the movies because he didn't agree with the flatness and bloodness of the movie creation. The original comics had a very deep narrative that you actually need to see where he comes from. Did I answer your question?
Thank you. So there's a last question over there.
Okay, if I may, I would like to have like a very small comment. I absolutely do agree with you that the imagery we are using is holding us back, and this is like spot on and well job, but job well done. But none of the images that you showed are actually connected to the original cypherpunk movement because they didn't have any image. It was just a mailing list. Very traditional mailing list that didn't even allow to attach any imagery. The closest they were getting to having any visual identity is when 3 of the people from the original cypherpunk movement were featured on the cover of Wire magazine, and they were wearing masks, but they were very different masks. They have nothing to do with Guy Fawkes, and it was not their idea to wear the mask. That's one thing. Second, they used one pretty cool image that became like really associated with them, but not with the movement, but one of the campaigns that they were running. Like in the early 90s, there was this danger that US government will impose a surveillance mechanism on a communication. It was like Clipper project. And what Cypherpunks did was like basically they hijacked Intel logo, and instead of Intel inside, they put Clipper inside. And this became like a sticker that they were distributing in many, many places. And so this was like quite successful. But everything else that you showed had absolutely nothing to do with cypherpunks. And one last thing, cypherpunks, the name itself, it's not that they created. They were not considering themselves to be a cultural movement. It was basically a joke from someone who was looking at them and commenting how they are like approaching things, but they were not punkish at all.
Absolutely, yes. And that's how branding works. It's not what you say about you, it's what others say about you. So I encourage you, open your laptop and Google hacker icon and see what you have in the answer. Just Google Cipherpunks and see what Google gives you. And it's, yeah, that's the whole point. The world, and we know which powers, are engineering the reputation of cypherpunks, which is going to the minds and hearts of people outside of crypto bubble. And the call is not being passive around this, but actually do actions to create the image that we want to have, not what happens because some other very powerful media narrative is shaping how people see us.
Thank you very much. So our next speaker is going to be Vivek. He's a cryptographer and designer at Cursive, working on cryptography for human connection. And the topic of his talk is going to be making defensive technology offensive, how to get cypherpunk ideals to the masses. Please welcome Vivek.
Cool. Hi, guys. So my talk is going to be about basically like focused on cryptography as a defensive technology, because that's my area of expertise. How we can take various cryptographic tools that are super powerful and try to find ways to communicate them offensively. And maybe, yeah, just to be clear, this is more like encryption, signatures, EPs, this sort of thing. Obviously, under the umbrella of like DAC and defensive technologies, there's lots of other stuff going on. And I think how I would personally define cryptography is that it's the art of making things hard to break. In this definition, it is like very inherently a defensive technology. You're literally trying to make tools that is very difficult for adversaries to forge or break into or otherwise sort of damage the integrity of. And I want to look at just a very small set of examples here. This is not comprehensive at all, but at one really prominent use case of privacy-preserving technologies in the wild, which is VPNs. And VPNs, I think, if any of you guys have been to like New York or Chicago or a couple other major American cities, you might have seen these like Mulvad VPN ads everywhere. For context, I personally use Mulvad, so this is not really a dig at them, but a lot of their ads are very sort of like intense cypherpunk kind of vibe of like, you know, like a bit of both like hopeful but also kind of like fear-mongery. And I honestly am not sure how successful this has been for them. I definitely know for myself, like I got Mulvad before these ads came on, and like when I do see them in like the subway and the train, I'm like, I always think like, is this like, do people want to see this sort of thing? And like one reference point in my mind that I have is NordVPN, a lot of these other VPNs. This is not actually a ad from them, to be very clear, but if you're a big YouTube user, you know that like Nord and Express, these sort of VPN companies are like major funders of like every YouTuber. And it's really interesting to see how that marketing has changed over the past years. I feel like initially it was very much focused on like, oh, like this will protect you from like, you know, your internet provider seeing your history. And often that's still mentioned, but actually most of the time now, the emphasis of the ad reel is always on like, you can watch Netflix in other countries. You can like do this like new, like you have this new affordance from using this VPN. And that's always kind of like what they like talk about for a little bit longer. And I feel like it is a very good representation of the fact that like, I think users will generally respond to things that are value adds and not purely sort of defensive measures against like some sort of like threat. And to be clear, like I'm very much a cypherpunk and I like deeply believe in this technology, but at the same time, I also believe that if we're not able to do this sort of like communication work, we're not going to be able to get users the defense and safety that they deserve. And so I want to talk through just a few different kind of like high-level affordances that I think are worth leaning into and talking about more. The first is the idea that privacy is really ownership. And I think ownership is something that a lot of people feel a lot more viscerally with stuff like, you know, big social medias, like hosting all your photos. You don't own any songs anymore with Spotify. And I think there's a general sense of like, this is something that people like don't have that they wish they did. And in general, I think like one really nice thing is that with cryptographic tools, with signatures, with like signed data on all sorts of different things, you get to actually like own your own data and like have it be verifiable. But then if you want to actually maintain privacy on top of this, like it works hand in hand with other tools like ZK. And really, like if you own something, it is almost to some extent like private to you. Like you should be able to sort of like keep it to yourself unless you want to share it. And a lot of cryptographic tools give you exactly that. Another is the idea of user consent. And this comes up a really interesting way with something called multi-party computation, which is this cryptographic tool where multiple parties get to sort of do a computation on their private data. There's actually a really nice feature where if one of the parties like leaves the protocol or otherwise just decides to like, you know, that they don't want to be a part of it, no result is reached. And I think this is actually a very nice like positive feature where it's usually viewed in a lot of protocols as like a bug, where user consent is almost like mathematically required. And I think this is like an offensive, useful thing that people would be able to understand. Another this idea of portability or interoperability or verifiability, like they're all kind of the same thing. And I think a bunch of really cool use cases of this. Like one is like portable social graphs. This is like an app experience that I've been building with my team where you're essentially tapping different folks and building a private social graph that also you can take with you to other apps as you wish. And I think this is something that a lot of us are feeling now when we're like locked into sort of social medias that aren't really working for us anymore. Another really good example is just all personal data. Stuff like ZK email enables you to take things in your own email and basically make proofs about them, share them with other people in a way that means they don't need to just live in one service. And finally, I think an underrated one is efficiency. There's this new idea that we've been exploring called narrowcasting, which essentially, basically, if people do have their own ownership and privacy over their own data, you can basically send messages in a way that will only be read by the people who like match this criteria. And so in a sense, you can actually use cryptography to more efficiently like disperse information in a way that's privacy preserving. Really quick, where you can experience this, we have a booth downstairs, my team Cursive, where we're showing an app experience that has a bunch of these different features baked in. One thing I'll call out is something called private set intersection, which lets you see what you have in common with other folks. And yeah, there's gonna be some more features added in. This is where it is in the booth. And yeah, that's the talk. Thank you.
Thank you. So we have time for a few questions. Please raise your hand if you have any question. No question? No. Okay, well, thank you very much. Oh yeah. We can have a quick break and we'll be back at 10 past 6. welcome back. The last, no, it's not last, sorry, next to last. The next speaker is going to be Max. He's a Senior Developer Relations at NIM Technologies. And the subject of the talk is going to be From Packets to Privacy, Understanding and Evolving Network Security. Please welcome Max.
Cool. Hi, everyone. Yeah, the talk says Max Hampshire and Medamore. It's just me today. So yeah, packets to privacy. I am Senior DevRel at NIM. We're a company that builds mixed nets and a decentralized VPN product at the moment. I'm going to give you a bit of a tour of a bit of a flash drive through how packets move through networks, just so we're all on the same page, how inherently insecure they are, and how we can try and protect it. So initially, how packets move through a network. So we're all on the same page for the rest of this conversation. Data is sent between two network devices in packets. Packets are just chunks of data, right? So you don't have a stream to whatever server, whatever RPC endpoint you're actually trying to connect to. You send all the data in chunks, just so these things can multitask and talk to multiple things at once, right? Packets themselves, broadly speaking, contain a header, which has a bunch of information about the protocol, the type of content that's in this packet, the origin, IP address, and where the IP address that it's going to, right? Which correspond to physical space as well. Then you have the payload, which is your actual data. Sometimes you have tailors as well, which have more information. I'm not going to go through this whole list. You can take a picture or come and talk to me afterwards. But this is the metadata, the data about the data that is exposed by sending packets unprotected through a network between two devices. So where it's coming from, where it's going, the location, when, the type of packets, higher order patterns like the signature, what it kind of looks like, repeated communications, maybe also like device IDs, accounts, email addresses, cookies, fingerprints, all of this kind of fun stuff. And this is ultimately because when the internet was made, it wasn't made with network privacy kind of in mind. And the situation at the moment is that network traffic is captured and analyzed both by governments and corporations kind of en masse. They just blanket capture everything. And what they essentially try and do is, using machine learning, try and find patterns in this data. Who's talking to who and when, where you're located, what kind of traffic is being sent, and then relationships are inferred from that. Why are you only talking to you after midnight? What's the nature of your relationship? All of these kinds of things, right, so which can be used to de-anonymize you. There's a lot of different approaches that people take. So if we look at this diagram, right at the bottom, we have your kind of centralized VPN, shall we say. All you're doing is you're kicking the trust down the road. You're sending all of your packets to a VPN provider. Their server then forwards it on to wherever you want to go, right? You're not able to defend against anyone who can see the size and the timing of your packets and be able to infer what you're doing. Maybe you're downloading a video, maybe you're kind of getting your emails or something. And that is a centralized point of trust that you're trusting that that VPN provider will not sell your data and or when they are subpoenaed, give your information away. Tor does a bit better. It doesn't have a single point of failure in that regard, but against someone who can watch kind of the whole internet, which is kind of the situation we're in now, then they can still be de-anonymized. Tor does not add noise to their connection. It doesn't pad the packets so they're the same size. You can still do traffic timing attacks and all of this kind of stuff. Mixed nets, however, fragment your packets into encrypted Sphinx packets, all the same size. They all look exactly the same. Individual packets are routed differently through a decentralized network of mixed nodes that delay the packets variably as well. So what you're doing is, and we also have cover traffic, so there's kind of hiding a signal and a noise idea, right? So what you're doing is you're reducing the capacity for an observer to be able to pull patterns out of looking at this network traffic, right? To be able to de-anonymize you. And another technology we're working on as well, ZK NIMs, which are anonymous credentials for payments, because non-anonymous payments are a problem. I want to pay for a privacy service that helps me out, even if I want to pay with Molvad, and I want to pay in Zcash or use Railgun or Monero. They're still susceptible to network de-anonymization, and generally will have a small anonymity set of people who are using that stuff to pay for a VPN. However, privacy loves company. You need to have as big an anonymity set as possible, the possible sets of variations of actors to basically make this pattern finding impossible. Therefore, you need to be able to construct a way where people can actually pay in fiat or pseudonymous cryptocurrencies, right? But the usage is cryptographically unlinkable to the actual payment. So I can basically say, yes, I've paid for this in, with my credit card. However, you can never tell when I'm actually using this credential to access this privacy service itself. There are also selective disclosure credentials, which means that you can prove certain things about yourself, maybe that you have paid for something, and in a generalized sense that you've gone through, you can pass KYC, you've done another payment, you can vote in a DAO. It's decentralized because it's generated by our validators, and it's a combination of the Coconut and offline eCash schemes. Finally, NimVPN is the first kind of product app that's being built on the Mixnet for network traffic protection. So we are using ZK NIMs for private, unlinkable, re-randomizable payments and access credentials. It has two modes: the anonymous mode, where it goes into the Mixnet and you get the full metadata protections of the Mixnet, and it also has a two-hop dual tunnel-in-a-tunnel WireGuard, which is using the outside fringes of the Mixnet infrastructure. If you want to, we have an open beta right now. Also come and talk to me afterwards, and I have flyers with credential codes on them so you can try it out. I am also DevRel. If you want to build with this, because all of this that I've just said also applies to all crypto apps, wallets, everything, check out our Builder docs or come say hi afterwards. Thanks.
Thank you, Max. So do we have any question? Oh, over there.
Thank you. So if someone is using, there's the simple mode that's faster and the more complicated node.
Yep.
If someone is using the simple node, what can the government find out about me?
Okay, so you still, the speedy mode, where you have tunnel in a tunnel, right? You're disintermediating. None of the infrastructure that your traffic is going through, neither of the gateways that it's passing through, can have the full picture of either where your traffic is going or where it's coming from, right? So you're breaking those two things apart. NIM also has anonymous reply systems as well. So you can talk to a service and then you kind of send, let's say, pre-addressed envelopes along with that traffic. So the replies are all anonymized. So the people you're talking to don't know who you are, basically, right? So you never dox yourself. It doesn't have the addition of the noise and the mixing. So there is that to be said. One of the things that we want to aim for with this is split tunneling. So then you kind of get to a point where if you can capture, say, all of your devices' networking traffic, and then the stuff that is essentially asynchronous, messaging apps, email, anything that's not like browsing and streaming, basically, you can send through the Mixnet mode. And then for the other stuff, then it's still better than the vast majority of other options out there, basically. Yeah.
Yeah, I started using it yesterday. Thanks.
Sick.
Do we have any other question over there and there?
Thank you for the talk. Just a question. So if you want to have a decentralized VPN solution, I assume?
Yeah, that's what the speedy mode is, essentially, yes.
So the exit nodes, the traffic is basically internet traffic that comes out at the end.
Yeah.
So how do you protect those node operators from malicious traffic? So if there would be like illegal content being downloaded from the location where I'm at as a node operator?
We're relying on using Tor's tunnel list. So we're basically like, Tor and a bunch of other people have had this problem for a very long time. So we're kind of using a lot of the public resources they have there in terms of the block lists and everything that they maintain. So we're starting off with that, but we're also working a lot with our operators and kind of putting together, making sure that everyone's running in a particular legally okay way and that they have protection as well. But it's a thorny problem. It's a constant problem. But yeah.
Okay, well, thank you very much. Unfortunately, we won't have time for another question. Thank you very much for your presentation. And please give some applause to
Also,
Max.
anyone who wants t-shirts, I have a bunch in my bag for questions and stuff afterwards. So come say hi.
Thank you. And so the next speaker is Manu Alzuru, founder of ETH Barcelona and Block Drivers, and founding members of API3.org. He's also a partner at Own.fund and a member of MetaCartel, an advisor to multiple Web3 projects. He's going to talk about Solarpunk versus Lunarpunk, the evolution and integration of these movements. Please welcome Manu Alzuru.
Hello, everyone. Thanks for coming today. I'm going to talk a little bit about the solarpunk versus lunarpunk, the evolution and integration of these movements. So before we talk about solarpunk and lunarpunk, maybe we go a little bit on history. Actually, thanks to the NIM guys, yesterday they did a sick presentation about the punk movement. Thank you for that. Shout out to them. So yeah, let's start very quickly here. So the punk movement in the late 60s and the mid 70s actually started as a music movement. Who knew here that actually the punk movement was a music movement? Okay, perfect. There's a lot of people that do know that, which is really good. What happened there is that there were people that were a little bit depressed because, or not depressed, just not happy with the state of the rock scene. The rock scene became a very commercialized thing. So the punks, they were against this commercialization, they were against all this mainstream and this anti-establishment. They were like basically anti-establishment. So they came up together and they started to create their own environments. They started to create their own culture. They started to create their own way of dressing up. They started to create their own ideals and so on. And the main ethos of the punk movement was do it your own ethic, valuing the self-expression, the personal responsibility, and the direct action. After that, we had in the early 80s, we had the cyberpunk movement. And the cyberpunk movement it started first like a sci-fi type of thing. So basically, someone, I don't remember exactly the name, wrote a novel about cyberpunk, and also cyberpunk was started to be mentioned more and more in literature in the early 80s. These sci-fi stories that were being created were basically anti-authoritarianism and kind of like showing like a resistance against the state or against like any form of coercion. Another thing that is important to mention about the cyberpunk movement was that this let's say, movement was created thanks to a lot of literature, a lot of movies like Blade Runner, and more, let's say, films and different, let's say, forms of media that was basically showing to the world that we're going to be living in a world where there's going to be a lot of oppression and that there's going to be a lot of control by the different organizations, and not necessarily the state, but actually the corporations. Then, in the late 80s, there was also, again, a new sci-fi term that came up, which was the steampunk. And the steampunk was kind of weird because it came after the cyberpunk. The steampunk, it came after the cyberpunk. Again, the cyberpunk was like this idea, this futuristic, dystopian scenario where, corporations were going to attack the individuals, and basically we're going to be surveilled, and so on. In the steampunk, they were imagining themselves, even though they happened in the 80s, they were imagining themselves that they were in the Victorian era, and that they were imagining in the future how let's say, the steampunk type of, let's say, culture will look like. The steampunk, for those that are not aware, they usually use a lot of gears, a lot of mechanical things. If you Google quickly steampunk, you probably see that a lot of people have been like going to festivals with this type of let's say, how would I call it, aesthetic. Then the cypherpunk. The cypherpunk came in the early 80s, and basically was with the idea of creating more encryption and creating, let's say, more tools that will allow people to communicate directly to each other, end-to-end. And yeah, basically, the main ethos is privacy, freedom through encryption, and digital autonomy. Then came up the solarpunk movement, and the solarpunk movement was in the mid-2010s, and the idea of the solarpunk movement was basically to have kind of like a more optimistic view of the future and how we can use technology for the betterment of humanity. And then later on, in 2020s, the lunar punk movement came out, which was a movement that was basically around a lot of mysticism when it comes to privacy and also the balance between the light and the dark or the shadows, or what they call it, the dark forest. And this movement emphasizes cryptography and privacy tools. This is the first video that actually explained a lot about the rise of the lunar punk. I'm not going to show you the video because I don't have time, but afterwards, I'm going to share with you the slides so you guys can see. But one of the things that they say in the video is that solarpunk hackers are creating transparent infrastructure for funding public goods. And that was kind of like one of the things that they said that is not necessarily good. Also, that the lunar punk has been forced to break away from the solarpunk legacy, which is basically all of this technology with Ethereum that is very transparent and very open for everyone. And yeah, basically I started tweeting to the people that created this video and say, hey, actually I find that you guys are kind of like being a little bit populist and using a narrative against the solarpunks, when in reality, a lot of the solarpunks, we do care about privacy. And actually, Rachel, who is the person that is behind the lunar punk movement, she started replying to the tweets and saying, well, the article is merely pointing out authoritarian tendency within the solarpunk ecosystem. And yeah, basically she was saying that Proof of Humanity and Gitcoin, they are not necessarily really aligned with our values. Here, there's also a video that talks lunarpunk versus solarpunk versus lunarpunk with Kevin Owocki. Also, we have it in the slides. You guys can check it afterwards. And yeah, basically what happened afterwards is that when we started having this conversation with Rose, we realized that a lot of the things that the lunar punks believe are very similar to the things that the solar punks believe. I myself, I was calling myself a solar punk for a lot of years until this new, let's say, narrative of the lunar punk came out. When this new narrative came out, I stopped calling myself a solar punk because it was not really clear what a solar punk was and so on. And I'm saying all of this to you guys is because it's important to understand that we are creating these movements. We are creating them using language and using let's say, narratives. So that means that we need to be very aware and very conscious of like the language that we use when we're creating these different type of movements. So, as I said before, we realized that a lot of the values that the lunar punks said that they have, and the values that I consider that I had as a solar punk are actually very similar. But if we extrapolate all of the things that the solar punk or lunar punks are saying, one thing we have in common is that the solar punks, cypherpunks, cyberpunks, or any of those punks movement, the only thing that they care about was protecting their community and having a better world for their community and for their humanity. So again, if we extrapolate all of the differences between all of these different movements, the main common denominator is that word, care. They care about their communities. So what is the highest form of care? To me, that's love. And that's basically why I'm calling myself a love punk. And that's it for today. If you guys want to learn more about the presentation, there's a lot of videos there, very informative videos. Check out the QR code and connect with me. And yeah, let's chat more about the new movement, love punks.
Thank you very much. That's a wrap for today. Unfortunately, there won't be time left for Q&A, but perhaps you can ask directly a question to Manu. Thanks again for your presentation. So as I said, that's it for today, but you can come back tomorrow. It will still be under the format of Lightning Talk. So yeah, have a good evening and see you tomorrow. Bye.
Bye.